Oregon GIS user group. We're now recording for attendees from our user group that can attend today. We're going to post this on our website probably for about a month or so for members to access that. So we got a really powerful lineup of speakers today, so I won't talk too long, but my name is Jennifer Kirkland. I'm the new GIS specialist for the Southwestern Reserve out in Charleston, Oregon here. I'm going to introduce my coworker here, Sabra Comment. She's the coastal training coordinator, and let her speak for a few minutes. Yeah.
So for those of you who are familiar with SCUG, the prior coastal training program coordinator was head of it. The group is meant to cover COOS and current GIS professionals need to discuss a wide variety of topics impacting the GIS industry. The purpose of SCUG is to promote the GIS industry, so GIS users, and advocate for the local GIS users, data, and technology. So this was a group that had been going for quite a few years prior to COVID, and was reconvened unofficially in the fall of last year. So going forward, we're hoping that we can have quarterly meetings, with every other one being a skill building workshop. This one, but to that effect, we are definitely looking for members. So if you are interested in becoming a member, if you aren't already, please make sure to include your contact info on the sign-up list. Some things that we will be looking for in the near future include updating and maintaining the web page, focus areas, steering groups as we're kind of figuring out where to go in the next near future, as well as a logo design. So those of you that signed up on Eventbrite, you probably saw that the logo there. That's a temporary placeholder. Our old logo was not digital one, so we're looking for someone to take the initiative and come up with a cool new logo, and there will be a surprise involved in that. And just some logistics, as this event is sponsored by the South Sloan Air Coastal Training Program, unfortunately, as most of you know, there are some reporting requirements in order to continue. A post-program evaluation is up here, if you can fill that out. Those of you online, the same evaluation will be emailed out to you if you did sign up on Eventbrite, because otherwise I don't have your email. And to those of you who do fill it out, there will be a small prize, very nice water bottle. If you can fill out one of those evaluations and then put your name and contact info on the next card, I will be throwing that out of a bowl today. Sorry, those of you virtually, I can't really, well, to be discussed, actually. I might be able to get a separate prize for you guys. And lastly, a reminder that at the end of our program today, which will be ending at 5, at least for the speaker portion, we'll have an informal social hour. If you can't stay for the whole time, please make sure to need to leave early. Please make sure to leave between speakers, if at all possible, to and with that, I will hand it back over to Jennifer.
Okay, thank you, Sabra. So a few housekeeping things. We are hybrids. We have people online, we have people in the room. We have just too many excited people today to hear about GIS, so thank you everyone for coming. People here, the bathrooms are like right out the door and hallway to the right. We found the location, so nice work. If we here in the room, we have a paper sign-in sheet, so we can get your contact info for future events. People online, if you would like to drop your email in the chat, so we have that, and I can add you to the email list if you're not already on it for SCUG events. So without further ado, action pack schedule. Since most of our presenters are virtual, they're not going to have the ability to see everyone raise their hands or ask questions. I'm going to ask that the presenters present, and then at the end we have 15 minutes for Q&A Then we can open up to the room for virtual folks to ask questions. So if we could just hold our questions for those times. I think I'll start. Our first presenter I did see was online, so I'm going to give a quick introduction here. Our first presentation is an overview of photogrammetry in the BLM. Presenters are Jake Slider, is a geospatial analyst with the BLM National Operating Center Geospatial Imaging Services Section. That's a mouthful. Federal government, I'm surprised there's not a great big acronym for that. Jake has worked with UAS and photogrammetry since 2014, both at a biological research station and with the BLM. And his coworker, Mark Gavinsky, is a geospatial specialist within that same division. Mark has worked with UAS and photogrammetry with the BLM since 2017 and also specializes in close range photogrammetry. So I will turn it over to our presenters.
And Jake, are you going to present first?
Yeah, so I'm actually going to be, can you hear me okay?
Yes.
Great. So I'm going to be handling the presentation. I think Mark may drop in here. So thank you for the invitation to present. And thank you to Tristan specifically, who is in the BLM, I think Myrtlewood field office, for bringing this to our attention. So as Jennifer mentioned, we will be kind of presenting an overview of photogrammetry within the BLM. And I'm going to turn off my camera and just kind of rearrange here real quick. But I'll go ahead and start sharing my screen. I noticed here on my end, at least, maybe I have an outdated version of Zoom, but I don't seem to be able to share just a screen. That seems like it's gonna force me to just share an application. So my plan was to kind of bounce back and forth with some data. So I just say kind of bear with me as I go back and forth there. Hopefully that's not too jarring. So we'll go ahead and get started from the top here. Is this screen coming through okay?
There we go. Now you're in presentation mode.
Yes.
Okay. Yeah, so yeah, thanks again for the invitation. My name is Jake Slider, and actually since yesterday, I'm now the Bureau's photogrammetry and elevation data lead at the National Operations Center based in Denver, Colorado. I'm here with Mark Gapinski, who is a geospatial specialist in our section. And so we're just going to go a little bit of an overview of photogrammetry, talk a little bit about its history within BLM, but really kind of focus on a few case studies. And I've been pretty indecisive, to be honest, about how to approach this presentation. Not too familiar with the audience there. But the upshot of that is I have a ton of material here, more than I could ever imagine to cover in this time. So I would say, you don't have to be polite if I'm starting to get to my time. Feel free to just let me know, and we can certainly wrap things up there, within time and leave room for questions. So I think, a lot of the audience here probably has at least some familiarity with photogrammetry. You've at least heard that term. You're starting to understand a little bit about the data and how it may be used. But with our group, we often define photogrammetry as the art, science, and technology of obtaining kind of reliable information about objects and the environment through images. And that's a very broad definition. I think so broad to the point that it almost is not very helpful, but I think it still covers it. But when we mention photogrammetry, often what we're referring to specifically is using two-dimensional imagery to derive three-dimensional data. And in a nutshell, basically what this means is that we have imagery that is collected in stereo. So it has basically different imagery taken at different perspectives of a given object or feature or area of interest. And with that, those different perspectives, we're able to generate three-dimensional, often GIS-ready data for resource management or whatever other application we're trying to pursue. So this photogrammetric processing can create a number of different types of data, which are often, very familiar to us as GIS professionals. It includes things like dense point clouds, which is, a three-dimensional data set often distributed as a LAS or an LAZ file, similar to LiDAR, which has both structure and color derived from this stereo imagery. We can take these point clouds and rasterize them, turn them into digital elevation models to kind of work in a little bit more about in a 2D sort of environment in GIS. We can generate three-dimensional meshes, kind of similar to, like our older tin data sets, as well as textures created from these photos, which you can drape over the mesh for visualization. We can also, since we're kind of basing this data on on imagery, we can also create orthomosaics. So that's basically a mosaic of imagery where we have corrected for the inherent terrain and sensor distortion within this imagery to create, a high resolution base map where we can make accurate planimetric sort of measurements. Hopefully, I think many of you are probably already a little bit familiar with these sorts of data. And you may be familiar with photogrammetry in general, but a lot of us kind of think of this, I for a while was kind of thinking this as kind of a new technology before I moved into this role at BLM. When I really discovered that, photogrammetry is not necessarily a new thing. It's been around for, a really long time. We have in one of our trainings a little bit more of a history of photogrammetry, which we certainly won't get into now. But some of the basic, some of the principles date back centuries, and some of the actual practicing of photogrammetry goes back, nearly a century or so. And within BLM specifically, we've had a kind of a photogrammetry component at the National Center. I call it the National Center because it's kind of changed names a few times. But we've had a presence with photogrammetry in our group basically for almost the last 45 years. So starting around the 1980s or so, we had a small group of practicing photogrammetrists who were working on basically really specialized equipment. So we can see some examples of some of the analytical stereo plotters, as well as one of our retired colleagues now, Nefer Matthews. And we're generally working with a very small type of data set. We're working with aerial film, typically captured on aircraft with metric mapping cameras, working with basically image pairs or strips of images and producing drawings or plans, topographic maps and things like that. As technology changed, we're starting to be able to incorporate this data in a little bit more of a digital environment, including digital imagery. But it was still, even through to the early 2010s, a fairly specialized discipline with a very kind of a specialized set of equipment as well. So if you're like me, you may have started to learn about photogrammetry over the last 5 or 10 years, and you may, you see how common it has become, how many people are talking about photogrammetry and using photogrammetry. And I think even within the Bureau of Land Management, we've gone from a small subset of experts to tens or even 100 or so people who are practicing photogrammetry to some extent or another. And so I think it's often kind of valuable to think about, what has changed? Why are we learning and using photogrammetry so much more now than we were, even just a couple of decades? I mean, it's been around, but it wasn't necessarily something that was front and center in a lot of our minds. And Obviously, over that time change, there are advancements in computing power. We're getting more powerful computers. So I think that goes almost without saying. But kind of beyond that, we're also seeing advances in kind of computer vision, which has really opened up the ability for kind of structure from motion photogrammetry to become accessible and widely applicable from a lot of different users. And so the way this works is, basically, we've seen a lot of increase in the types of algorithms, starting with SIFT in about 1999, that are designed to look at imagery and find prominent features, as well as match those features with other images. And so what we can see here is an example from kind of a forested environment where we have overlapping or stereo imagery. We have, one of these algorithms which can detect and match features across those images. And so this leads to a couple of key changes. First, it allows us to, in photogrammetrics processing, start with the imagery, matching features, and then work backwards to figure out how our cameras were located and positioned, as well as basically figure out some information about the camera itself, which we don't necessarily have to know a lot about to begin with. So this allows us to capture data, stereo data, much more freely, and use even just digital, just point and shoot sort of cameras. So it opens up a lot of other kind of data capture scenarios. And when you combine this with uncrewed aerial systems or drones, this really kind of allows us to capture imagery in a way which I think was almost unimaginable, even just not that long ago. Most of us in the Bureau flew a lot of our projects with the 3DR Solo, which is pictured here. That's getting a little bit older now, but has been one of the major workhorses within the Bureau. And so this is a way where we can get these cameras into a position to capture stereo imagery in a way that's safe, and even a way, in the past we've often used aircraft to capture stereo imagery, but you can get a drone really in a much more, a wider variety of places. So it really kind of opens up the data capture a little bit more. So this has led to the last decade of our photogrammetry presence within BLM and the National Operations Center, really focusing more on kind of high-end consumer grade equipment, digital cameras, some of these kind of standard drones or UAS. And it also allows us to create many more data products with this structure for motion photogrammetry, which also allow us to address kind of a wider base of customers within our group. So whereas we were primarily working with, cadastral surveying programs, maybe some of our engineering groups, we're really working with a lot more customers now at this point. That has led to, really a lot of different applications of photogrammetry for BLM. I won't read through each of these, but we've been able to touch on quite a few more types of projects now that we have UAS and drones to capture imagery, as well as kind of structure for motion photogrammetric processing. So initially I was thinking about kind of just treating this a little bit more as a presentation, focusing on like 3 or 4 different use cases. I think I'm going to focus on my first 2 a little bit more, and maybe just try to dive into the data in a little bit more detail than I had initially planned. So I think one of the big interests from this group, based on what I've read from some of the emails, is basically one of the big interests is obviously capturing imagery, stereo imagery with drones or UAS, and processing that into data for use. And so I'm really going to focus on that in 3 or 4 use cases, starting with that. So I mentioned that within photogrammetry, we are using stereo imagery, or imagery of an area of interest, an object of interest, that is captured from slightly different perspectives. And so basically, in most of the cases, what we're doing, especially with a UAS or a drone, is we are capturing this stereo imagery in flight lines, doing basically a lawnmower pattern over an area of interest, and using that to have an entire area in stereo so we can generate three-dimensional data. So here's an example where we have this over a mining area. So we have basically a little stockpile that is was derived from this stereo imagery. In this environment, we're often generating point clouds. Those point clouds can then sometimes be classified to identify which points are representing vegetation. We can remove those and basically then have either a digital surface model, or if we include those points, or digital terrain model. One limitation of photogrammetry, certainly compared to LiDAR, is that we can only create data based on what's visible in photographs. So if we have a lot of vegetation, we can't really see what's underneath that. So within reason, we can remove some of that vegetation and look at terrain, but often we are just limited to looking at a digital surface model. As mentioned earlier, we can also generate orthomosaics. So this, mining is really one of the areas where our group has worked with UAS data and photogrammetric data really quite a lot. And as I look out at the landscape of kind of different and new users, I definitely see a lot of instances of people using these sort of technologies for mapping mining areas and looking at production. So we're interested in this specifically because federal law requires the verification of material removed from mining areas that are leased from the federal government. So BLM manages a lot of the federally owned mineral rights. So often, a lot of, even in areas where the surface is privately held, often the federal government still owns basically what's underneath. And so private operators can be given contracts to remove, things like aggregate or other materials, but they're required to pay royalties to the federal government, to the taxpayer. And so it's on us then within BLM to basically make sure that they are paying fair royalties on the amount of material that they produce. But this is tricky because a lot of traditional methods for doing this are very labor intensive or they're very coarse. So often this has been looking at surfaces, creating surfaces with the GPS unit, walking over a surface, or having a surveyor, get a couple hundred points to kind of model a surface and do that over multiple time periods to see how that surface is changing, seeing how the volume of that area is changing. But photogrammetry provides us with a rigorous approach for generating accurate surfaces. So it seems like a logical substitute for generating surfaces for looking at production verification. And one of the benefits of the photogrammetry is that it can scale very well. So if we're looking at a small mine of a couple acres to a couple hundred acres, we could fly that with a drone and a camera, or if it's very large, we could fly that with a crewed aircraft, or even get stereo imagery from a satellite. So that's kind of one benefit of photogrammetry. And so I'm going to try to just go ahead and share. Like I said, I kind of, changed up how I wanted to approach this a little bit. So I'm going to go ahead and just kind of jump over to a couple of different windows. Are you seeing a 3D kind of model data set like within Metashape? Is that what's coming through on your end?
Yep, we can see that.
Okay. It looks like this is going to create several shares, so it could be a little bit messy. But we'll we'll kind of get through here. So this is an example of one area where where we have this stereo imagery, which was then used to produce some 3D data. Here, we're just looking at the tie points or the imagery, the features found in multiple different images used to kind of tie together this imagery. And then we can go ahead and build that out into, you know, a dense cloud, dense point cloud, which gives us a lot more detail on kind of the surface. And as I said, that could be kind of rasterized to produce a digital elevation model. Now, a lot of the work that we use with photogrammetric data, you know, in this production verification environment is often with used in kind of a raster. We often will convert that into a digital elevation model and bring that into a GIS. So I should be sharing my
Yes, we can see your pro project.
pro version. Okay, I'll just kind of mention what I'm looking at, and then you all can just let me know if you're not seeing it. So yeah, sharing this pro environment. So what I have here is basically two DEMs of a mining area. And so if we kind of go back and forth here, this is 2017 and 2018, and these were two mines. It's called the Indian Sunset Mine in southeastern Colorado. And so if we kind of tweak back and forth here, we can see that the basically there's mining activity going on in kind of this northern part, and we're also seeing some changes to the stockpiles throughout the site. We can then take a little bit of a look at the surface change. You know, we could subtract one surface from another and use that as a way where we can highlight areas of change. So areas where that surface has gotten lower would be represented in red, whereas areas where that surface has gotten higher would be in blue. And we often call this cut and fill respectively. So this is a way where we could then kind of see where has this mining area changed? Where is the activity occurring? It looks like it's often on this hillside, but it looks like there are also changes in some of these stockpiles. And so then we can take this a step further within a GIS and use some of these tools to, like a cut fill tool, as a way to kind of drill into this a little bit further and say, you know, how much material has actually been kind of removed from this area. So this is a little, kind of a little custom version of the cut fill tool I wrote that basically limits that sort of operation to a specific area of interest. But what this does is basically subtracts one surface from another, and then using the pixel area multiplies that by the vertical change to get a volume change. And the kind of the product out of that then is a kind of volume change between two surfaces. So since these were captured in November 2017, November 2018, we can then see how much material is removed from this site. And so when I ran this previously, it took about oh, here we go. So this area, I just limited it. I drew this area of interest down to the stockpile just to see how much that has changed. And so it looks like about 3,500 cubic meters was removed. There's a little bit of an area where that surface became higher, about 8 or 9 cubic meters. But again, the net change of about 3,500 cubic meters. So then we can kind of compare that to operator records to see, does that basically line up with the amount of royalties that are being paid out of that mine site? So that in a nutshell is you know, how we kind of approach a production verification problem. I want to shift gears a little bit here and Oh, I think I can get a little feedback here on what I'm looking at. So that's helpful. Let me go back to the presentation.
Yeah, we're still seeing growth. There we go.
All right. So one of the next projects I want to talk a little bit about is a project we were called upon to do in 2019 for the Gunnison Field Office in Southwestern Colorado. And this gets at really, I think, one of the big benefits of photogrammetry is, you know, especially combined with UAS, is that it's really easy to mobilize and get out in the field and collect and process data if the situation, if a you know, kind of an urgent need arises. And so that was kind of what happened for this particular project, where back in the winter of 2018, 2019, Colorado saw a really historic avalanche season, especially in March. We had I know that there was at least 1 week in particular, which had a series of very large winter storms causing avalanches throughout Colorado, but especially in southwestern Colorado. The issue here was that, you know, a lot of this avalanche debris was ending up in creeks. In Henson Creek in Hinsdale County, this issue was kind of complicated by the fact that there were a number of historic dams associated with kind of old ghost town mining areas. And so this really caused the potential for some catastrophic flooding in certain areas of the state. So we were called upon to basically respond to this emergency declaration in conjunction with other federal and state partners, and to basically map and quantify the capacity of this historic, the reservoir associated with this historic dam, as well as to document historic sites that may be removed or damaged as a result of potential flooding. And obviously there was the impetus to do it fast under an emergency declaration. So it was important to kind of get results quickly. And so that was really kind of, in a nutshell, what we were kind of looking to do here. Specifically, you'll note that in this dam, you'll see that it was breached a number of years ago as a way where water could kind of freely flow through here. But if we were to basically zoom out and move upstream, what we would see is that a fairly large avalanche came down the hillside right upstream, and you'll see that there's a lot of debris, including some fine debris, as well as some large woody trees here. Basically the concern was that if there was a large rain event, that a lot of this material could start to wash downstream and fill up that breached hole in the dam. And if that occurred, you know, that reservoir could start to fill up. And since this dam hadn't been maintained in, you know, 100 years or more, you know, it could theoretically give way and release a wall of water down the creek into Lake City, Colorado. So, as I said, the first objective for this project was to say, you know, what would it look like if this area basically started to fill up, if this reservoir, if the dam got kind of clogged up and this reservoir started to build up? You know, what is the spatial extent, as well as potentially the volume of this reservoir as well? So as I mentioned, you know, we can generate these three-dimensional data, things like digital elevation models, contours, things of that nature. And so what we were able to do is basically identify where the, you know, the contour where the top of that dam is located down here in the right end of this ortho image here. And then we can kind of basically track that contour to get kind of the aerial extent of this potential reservoir as represented in blue. Then basically did a point cloud classification to remove some of the vegetation and kind of a basic quick digital terrain model. And using that, we then basically applied a plane at this elevation and said, what is the volume below that plane? And this gave us an estimate of the volume that would be held in that reservoir. And so what we ended up getting after just a couple of days of work there was an estimate of about 60 acre-feet of water could potentially fill up in this area, which is less than a third of what the emergency planners had in mind. So this kind of spoke to them that maybe this wasn't as big of a hazard as initially expected. So perhaps, it wouldn't make a huge impact to remove that dam one way or the other. But basically, though, it was able to generate some information quickly for some of the emergency planners. At that time, though, we weren't unsure what the fate was, so we wanted to document some of the historic sites that were in this location. And so basically, this site actually, maybe just a year before this event, was put on, I think, at least the state register of historic places, maybe even the federal register of historic places. So we wanted to document some of these features that could be damaged or, as I said, removed in the case of the dam as part of this process. So here we have a couple images, and one of the things that we often do in our group is this archaeological documentation. And so if we move forward, we can see that we are able to generate basically these three-dimensional models of this area so that we could have a permanent record of these features, even if they were damaged due to flooding. So I want to switch over here to Sketchfab for just a moment, and we can take a little bit more of a look at those data, just confirming here that's what's coming through. So I would encourage you to, we can share a link. Mark, maybe you could, if you're on there, you could kind of share the link to our Sketchfab so you all can take a look. But Sketchfab is one way that we've been using to kind of share this data in a much more, easy to use framework. Often when we generate this data, it can be hard to get it in the hands of decision makers. But Sketchfab is nice because it allows us to make this data accessible to anyone with basically a browser and an internet connection. So here's the 3D model of that ULA dam, which was kind of the primary one we were mapping. So we can get this permanent three-dimensional record here, which is photorealistic and can also serve as kind of a teaching tool. So we can kind of make annotations here so that we can tell individuals kind of about this historic site, even if they're not able to visit it. If we kind of zoom out a little bit, just mention too that we were also able to document these kind of the entire complex as a whole, including not just the dam, but the some of the other structures that were still present. And it's just about there. Here we go. So we can see a little bit more of the context of the town itself. So basically number 6 up here is the dam. And for a long time, what it did was it sent water down through a flume. You can see a little bit of a collapsed flume right here. So like a wooden tunnel to send the water. Sent it down to this water tower here, which had basically like a water wheel, which would power the old mill, which eventually was replaced by a newer mill with a diesel powered process for, I believe this was primarily a gold mine in this area. So again, gives us a little bit more context on this site as well. And so taken together, this information was able to get in the hands of emergency planners quickly. And as a result, they decided to actually not proactively remove this dam. It's still in place. I was actually down there over Christmas and I saw that it's still as is, the same condition I saw it. But we also, kind of got this collection of, models which could then be used for people to explore this area in a little bit more detail. Shifting gears, I'm going to head back over to my presentation here. Another thing that we
We've lost your screen.
all right. Yeah, I'm used to Teams. I can share just my second desktop, and it usually works pretty well.
There we go.
There we go. Thanks for bearing with me. Another thing we frequently get asked to do is topographic surveys. And, we often, as GIS professionals, we rely on, LiDAR collections to do a lot of this sort of work. But, it's only recently that we're really getting good LiDAR coverage in the Western United States. And I think even in Oregon, it's still pretty spotty as far as LiDAR data availability. So often we rely on, photogrammetric data to help us kind of conduct these topographic site surveys. And so this is an area where basically the Colorado State Office was interested in doing some remediation. So basically in this area here, circling in red, there was an old oil well and storage tank that had been leaking into the ground. And so they're interested in reclaiming this site and kind of removing that hazard. And so one of the things that the engineers required, though, was a more up-to-date, more detailed surface with which they could do their engineering design work. So the way this has typically been done is that a surveyor would go out and collect, spend a week or two, spend a couple, collect a couple hundred points, maybe he's really ambitious, 1,000 or a couple thousand points. But just imagine kind of how generalized a surface you would get with just a couple hundred points when we're looking at, probably 100 or 200 acres here on a hillside. It would really be a very kind of simplified surface overall. So instead, and also in this area in particular, you can see a photograph. This is a very steep hillside. So in many ways, it would be hazardous for a surveyor to be kind of walking along the side here. So the way we approached this instead was to have the surveyor lay out, just 30 or so ground control points. And then we use those to position our photogrammetric survey that we conducted with a drone. And so as a result, then we can get this much more detailed three-dimensional model. And just a note here, which I have myself here holding the 3DR Solo, which we used for this project. And Mark is here on the left in the photograph down here. And so again, I'm just going to jump over to take a little bit more look at this project. So this is an area called, I believe it's called Woosley. And so we can see a little bit more detail on the site here. So again, we're talking about a fairly steep area overall. Just for scale, we can see some cars in the background here. And so if we measure kind of the elevation here at the road, we're talking about 5,324 feet, at the top, 5,600, so about 300 feet, almost straight up the side of the hill here. So again, very kind of steep sort of area. One of the things that you'll see though is we can also see that it looks like there's been some slope movement here, or maybe a little bit of a landslide there. So if we have an engineer who's trying to, reclaim an area, make it safe and inhabitable, basically, we'd have to have a lot more detail on kind of the surface. And so that's what we're able to get from photogrammetry, rather than having a surface based on, a couple hundred or a couple thousand points. We have a surface based on 100 million points instead. Just a note though, too, we do have a bit of vegetation. I mentioned that it's sometimes possible, to kind of remove that from some of our projects here, especially when we're working in a pretty sparse area. And so I wanted to just mention that is kind of one thing that we've done a little bit here and there is been able to remove, do some point cloud classification and remove that vegetation. And so here's an example where, as a whole, we have Again, just another perspective of this area. This is in Cloud Compare, which is a free and open source software, a very helpful software for doing a variety of analyses. But it also allows us to get at a couple algorithms for doing ground, non-ground classification. And so I just ran that on here just to see how it would do again. And this is a way where we were able to kind of remove a lot of that vegetation and then get basically something much closer to a digital terrain model, which was basically what the individual had wanted, the engineer had wanted in the first place. So if we take a quick look at that data in ArcGIS Pro, we can see kind of the original digital surface model that came right out of the photogrammetry software. But then, we were able to remove a lot of that vegetation and get much more closer to a digital terrain model. It's not perfect, but definitely got a little bit more closer to what the project requester had in mind. So that's another kind of common application that we are called upon to do. To go back over here to presentation. So shifting gears, you all may be feeling a little bit left out there in Oregon. So I'll just focus for a moment on one of the projects that I'm aware of in Oregon, leveraging UAS data in photogrammetry, which is monitoring timber harvests.
Hey,
So
Jake, I
BLM
think you're
work.
showing your, I can see your next slide screen and everything.
All right, let's see if we can share the right one there. Thanks, Mark.
Yeah, there you
Is
go.
that better?
Yep.
Yeah. So this is an area, this was conducted over in the Medford, BLM Medford District Office in conjunction with the State Department of Forestry. And so basically, BLM Oregon has a lot of timberland. They do give out, there are timber sales, to companies that will go and harvest that timber. But in certain areas, there are requirements to leave a certain amount of canopy cover. And that is largely to protect the northern spotted owl. And so in this office, basically they had the kind of the base map, imagery base map, as well as pre-harvest LiDAR. And they were able to kind of drape their orthomosaic and their digital surface model on top of that in order to kind of do an updated perspective on what the final results of that harvest were. Basically, was that operator in compliance? And in this particular example, they found about 62% canopy cover remain, which I believe is kind of adequate for the terms of that sale. I think I spent a little bit more time on a few things that I meant to, so I'm just gonna jump ahead a little bit. And I want to just mention that, a lot of our projects we've talked about have been fairly old. I was just actually doing the numbers, and it's been about 3.5 years since I've done a UAS project for resource mapping. And a large portion of that, it's not just COVID, but a large portion of that has been the grounding of drones within BLM, which has certainly hampered a lot of our efforts in terms of using these technologies. We're definitely starting to see some movement, light at the end of the tunnel, but what that has led for us to do, especially myself, and I would say Mark as well, is to maybe kind of focus on some topics that we didn't necessarily focus on as much before. And one of those is close range photogrammetry. And I just wanted to touch on this a little bit because I think many people who are coming to photogrammetry with UAS data don't necessarily think about the fact that, we can still use this imagery and these processing softwares which we're investing in and learning to create three-dimensional data of features that are kind of smaller in scale. So here's an example. We often use this for documenting petroglyphs or trackways for dinosaurs. So when we're doing this, we're generally creating kind of more photorealistic models that are scaled, but not necessarily georeferenced. And so here's an example when we were in the field in Western Colorado, where we kind of see this petroglyph here, and then its three-dimensional model on the right. And so I'm going to go ahead and share, take a look at one of the sites we did actually in northwestern Colorado. So this is actually some data that Mark collected. So this is an area where some native groups, I believe this was an area occupied by a Ute tribe, but basically they were conducting some farming further down the valley, and then they would find these kind of alcoves in the cliffside and build these granaries for storing their food that they were harvest from these farming areas. And so this is an example of really some of the really detailed kind of three-dimensional data sets we can calculate from photogrammetry using kind of a handheld DSLR instead of just, putting a camera on a drone. So I just wanted to kind of point it out that this is another kind of common application that we use within our section. So we can, if we wanted to, we could just kind of take a quick look at, kind of the length or size of features, kind of get that same sort of information. And if we turn on the cameras, what we can see is that basically Mark was just walking around this feature, taking stereo imagery in that manner. So that's just another kind of application that we're frequently using in our work. This sort of thing can scale, as I mentioned before. So, often we're not just doing sites, but we're working on, all the way down to individual little artifacts. So we frequently collaborated with the Canyon of the Ancients National Monument in southwestern Colorado, in not just documenting kind of structures and areas, but even documenting kind of little artifacts that were found at the area. And so here's an example just of a little visualization of, an artifact that was documented with photogrammetry kind of in the office and, creates a permanent record of that feature, that object. Just note one more thing, one more little area, and then maybe we can kind of wrap up. I think we're getting close to time. There have been some projects that we work on, especially documenting archaeological sites where we've combined this UAS and handheld imagery. So there's some caveats as far as how you would collect this data, but one area where we focused on this a bit is at a Pony Express site in Nevada. So here's an area where we have the actual Pony Express site. And basically what we did is we captured imagery at 50 feet with the drone looking straight down. That's what is symbolized here in pink. At 25 feet above the ground in dark blue here with the camera basically at an oblique angle. And then we were able to fill in some more detail with these light blue images with a handheld DSLR camera. And that's one way where we could get a much more detailed picture of this site. And so again, I would kind of point you to a Sketchfab. We have a couple of collections here of the of our work from this project, including some Pony Express sites. So we were just looking at this Sand Springs station. And so we can just see an example of kind of what that three-dimensional model looks like as a result of kind of combining these different data sources together. So this is just about to load, but I would also note too that, when we have a Sketchfab model, we can share that out individually. So we can kind of see some of that detail here. But we can also, take some of these data and include them in some of our other kind of common workflows for sharing data, like creating story maps. And this is something Mark created where he was able to share a lot of this data that we collected with the drone, processed with photogrammetry, and then shared some of these results with a, with a story map highlighting some of these areas. So here's a location of a Pony Express station. And then we were able to kind of layer on some of that high resolution imagery and then point it to one of the models as well. So I think that's maybe a logical spot to wrap up. I certainly didn't, I didn't get quite as far as, actually, I think I covered everything I wanted to. I'm going to put up my screen here just so we can have our contact information here. I guess with that, if it's time for that, we can transition over to questions.
Yeah, thank you so much for your great presentation. You guys have a lot of different projects. That's great to see. I'm just going to open to the room or virtually if people have questions. Everyone's just in awe of those really cool 3D models. Yes.
Yeah. I guess I didn't get a chance to, I didn't see Mark at first in here. I didn't get a chance to introduce him at first. I didn't see him at first before I jumped in. Mark, is there anything you wanted to kind of hop on and add to this?
No, but yeah, hey, Mark Kapinski here. Been lucky enough to do a lot of cool field work with Jake. And yeah, one thing I think you may have missed mentioning, Jake, is with the close range photogrammetry, Jake did mention that usually it's not geo-referenced, and I don't think we need to explain that term, but in terms of scaled, all the models are scaled with real world units, meters, feet, etc. And we essentially just use that by putting in a highly calibrated ruler within our imagery, which we refer to as scale bars. So when you go through the processing workflow, you flag out those points within your scale bar, just like you would with a ground control point, and say this distance is X, 1 meter, and then it allows you to scale the model so that you can do kind of precise measurements and volumes, just as you would with a traditional UAS survey. But yeah, I'll turn it over. I saw a couple hands up in the room.
Yes. So I work primarily in seafloor GIS stuff, so bathymetric modeling, and photogrammetry is something that we've been looking into for use with like underwater drones, like Sentry and autonomous underwater vehicles. Do you think that a lot of these techniques could be applied to seafloor photogrammetry where multi-beam might be failing?
So, that's a that's a question. That's kind of an interesting question, and one that I think I would typically say I wouldn't put out much hope for that. But we actually had a course a couple years ago where we had an individual from Fish and Wildlife Service who was underwater collecting stereo imagery of corals and was able to process that stereo imagery into 3-dimensional models of corals. So I think that there's, I think that that's a possibility, but I haven't ever heard of of photogrammetry being applied in a more kind of in that way in any sort of production or mapping workflow. I think obviously you would need to have a submerged camera because you can only see you can only make data from what's visible in the camera, and if you have the camera above the water, you wouldn't be able to see much. But as far as if you had clear water, you had that overlap that you were able to, maybe put the camera on a timer. I don't know. I'm hesitant to say that that's the route to go. A lot of those areas are done with the topobathy LiDAR with a green laser. But it's I think an area worth exploring if nothing else. But I don't really work in that sort of environment too much, so I'm hesitant to kind of stand behind recommending that.
Thank you.
Yes, was there another?
Yeah, I came in a little late and just missed what the photogrammetry software is that he's using. What's the name of that?
Oh, I didn't know that I actually mentioned that. Sorry. We use Agisoft Metashape. And that's basically kind of our standard within BLM, even I'd say within DOI. It has, a lot of the different you know, there's like Pix4D, a number of other ones. All of them will give you basically the same thing. I like Edgesoft Metasheet because it gives you a little bit more detail to really kind of drill down into the data and understand the errors and the accuracies in your data a little bit more. It also has a Python API where you can kind of automate workflows and create custom tools a little bit more easily. And it's a lot cheaper than Pix4D. It's way cheaper than Pix4D or even Drone to Map. So there are definitely some benefits there. I don't have an official position on that, but that's what we use is Edgesoft Metasheet.
Thank you.
Any questions from our virtual attendees? I don't want to forget you guys out there. Pause a moment for people to find those mute, unmute buttons. Anyone's questions? If not, we'll turn to the room. Yeah, Tristan?
I just want to thank Mark and Jake for doing this presentation. Really good work that you guys provide for us there at the NOC, and thanks for sharing it to the local users group.
Definitely, yes. Thank you so much for sharing your great projects.
Oh, you're welcome. Yeah, it's kind of interesting. There are certain field offices where, you know, we interact with a lot, and others we don't interact with very much. And I'm not sure I've actually interacted with Tristan too much, just because, you know, there definitely is a good photogrammetry and UAS presence there. So often a lot of that work is kind of done well at the field office level. So all being said, again, thanks for the invitation. Probably won't stick around too long since I'm on mountain time, getting towards the end of the day here, but thanks again for the invitation.
Yeah, thank you very much. Thank you. Yeah.
All right, have a good one all.
Hey, I'm glad to see everyone got up, moved around. You're not getting too comfortable at home. I'm sure you've got like your slippers on, your favorite drink, you're ready for the next presentation. Stand here in the front so you can see me. Welcome everyone that came in, snuck in. Make sure everyone's signed in on the sign-in sheet. If you snuck on online, you want to drop your email in the chat so we can get a hold of you for our future events. That would be great. I'm gonna move right in. So just so all of our everyone's on the same page, we have a speaker. Next session is about 30 minutes. If you could hold your Q&A till after the speaker is done, then we'll open up for questions from online folks and people in the room. But I'm going to go ahead and introduce our next speaker. What is ORURISA? What is it? It's a good question. So I've been getting it a lot lately. Restarting the SCUG group, which falls under that. So we have Nikki Hart-Brinkley is an independent GIS consultant based in Ashland, Oregon. She's on the board of ORURISA. She leads the Southern Oregon section and is the co-chair for the GIS in Action Conference for 2023. I'm going to turn it over to her and she can answer our question.
Hi, everybody. Thanks for having me today. I had really hoped to be there in person, but we had quite a lot of snow in Ashland, and school is closed today, and the passes were shut down, so I couldn't make it today. So thanks for having me. I don't know that I will need my full 45 minutes, both for presentation and for Q&A. I don't know about you guys, but I want to keep talking about photogrammetry. If you don't mind me going off script for 3 minutes or so, I'd really like to share a project that also involves BLM photogrammetry with a project that I've been working on with the Southern Oregon University Laboratory of Anthropology, as well as the BLM Medford. Does anybody care if I share that work really quick? It's cool, and you'll get to see more pictures of really interesting indoor LiDAR.
I say do it.
All right, cool. All right, let me make sure I get the right screen here. All right, here we go. So do you see my screen showing the Oregon Chinese Diaspora Project?
Yes.
Okay, so this is an amazing collaboration between archaeologists all over Oregon that brings together and promotes research and education on Oregon's early Chinese residents. And I will put into the chat in a minute the link to this website. The intent of this website is to bring together a whole bunch of different pieces and parts of information about this project throughout Oregon, and it's constantly being added to. But what I want to bring your attention to is this Buck Rock Tunnel project. So the Buck Rock Tunnel is just about 20 or 30 minutes from downtown Ashland here. And what it was is it had been started as part of the railroad project through Southern Oregon, but it was abandoned. And here you see part of that tunnel that was rediscovered in 1966 by a BLM forester. And this is what I really wanted to get into. I wanted to get into some of that photogrammetry and LiDAR data that BLM has been involved with. So here you see both of the tunnels and how these were going to come and connect together through this mountain. Here you see some of the field work that's going on here, some of the artifacts that are being uncovered, shoes were uncovered there. This is my friend Chelsea Rose, the archaeologist. And then we get down here to, this is Terrence Christian, who works out of the BLM Medford office. And he is on a special team, and I believe the name of the team is Abandoned Mines. So he and I think just one other person specializing going into abandoned mines and tunnels like this all over on BLM land and doing interior LiDAR. And some of the really cool work that they have done can be seen here on the hub site that I've created for this. And you get to actually walk through the tunnel without having to do the 2-mile uphill hike to see the one that is open. So I just wanted to show off a little bit more of the BLM's work. I just plug and play this stuff into the hub. The BLM archaeologists are the one out doing the really cool work. But I just wanted to share what some of my partners are out there in the field doing. And with that, I'll get to the less interesting stuff, but I hope you'll still find it interesting, even though it's not interior LiDAR. So let me go ahead and stop my share there. Get my other screen up. Let's see. Okay, do you now see my URISA, Oregon Urban and Regional Information Systems Association PowerPoint?
Yes.
Yes, okay. So what is URISA? So the Urban and Regional Information Systems Association was incorporated as a nonprofit GIS professional organization in 1966. Urban and Regional Information Systems Association does not really roll off the tongue, and there had been some talk about potentially renaming it, but we're stuck with it. It's a piece of our history now. So what URISA is it's an international organization for GIS professionals. It provides education and training and advocacy for geospatial challenges and issues. And it really is intended as a professional organization to support GIS professionals throughout their careers with essential resources like training and conferences and networking. You can access the URISA website at urisa.org. The website is going through some platform changes right now, so you may be redirected or may have to click on an additional link. But here you can find out more about URISA. You can sign up for a membership. You can access their education and other resources and volunteer for some of the fun initiatives that they have going on. Some of the really big stuff that they do every year is the GIS Leadership Academy, which I have not taken yet, but I hear wonderful things about. So for people who are moving through their careers and are headed toward like a management trajectory, the GIS Leadership Academy is excellent for meeting other GIS managers and really honing your skills toward a management trajectory. They also put on GIS Pro, which is a really big conference, and it was just held here in Boise not too long ago. So even though both the Leadership Academy and GIS Pro are towards the East Coast this time, they do move around the country so that we all have an opportunity to go to something that is closer to home. Some of the workshops that they offer on their website include this list here: emergency preparedness, equity and social justice. Some of those programs are really great. Next Gen 911, GIS strategic planning, ROI, return on investment, and preparing for the GISP exam. So that's one thing that URISA works really closely with GISCI, the GIS Certification Institute, on is GISP exams. So I hear great things about the workshop preparing you for your GISP exam that's available through URISA. And all of their workshops are have the GISP stamp of approval. So if you already have your GISP and need to keep up with your educational credits, all of their workshops account for that. They put out publications and online, they've got an online library and podcasts. They put out the GIS Professional, which is like their newsletter. They also do a salary survey. And the only reason I'm posting this is because it's from 2017. There's a new one due out. So don't get too excited about these figures. They are putting out a new survey, and then the survey results are going to be available to URISA members. So Oregon URISA has not always been a chapter of URISA, and that's a little confusing. So I wanted to kind of work through how this all came to pass and what that means for you as a GIS user and what it means for your user group as well. So a few years back, there was a One URISA initiative. And basically what that said is URISA International wants to unify and codify all of their chapters under one umbrella. It makes sense because we're all working towards the same general goals. And it brings all of the chapters under a model that unifies not only our vision, mission, and framework, but it also connects all of us together in the same umbrella where we can all network with each other in an environment that doesn't change from board member to board member. Really, it unifies all of the chapters across the world so that there's continuity in leadership. So previous to One URISA, it was possible to be a member of a chapter, but not of URISA. And so I'll get into that a little bit. I'll preface it by saying that no matter how much or how little you want to be involved in your local users group in Oregon URISA or at the international level, there is something for everyone. So if you don't want to sign up as a member, you're still going to be able to access the things that you've been able to access all along through participating in your local user groups. So URISA and all of my cases changed. I was kind of tinkering around with my design as I was listening to the photogrammetry session, and now I'm looking at it and all of the cases have changed. So anyway, URISA should be all capitalized. But I think it was 2 years ago, we as the board voted to become an official chapter of URISA. And so what that means is Oregon and Southwest Washington are now a chapter of URISA International. And you can find more information about URISA at orurisa.org. This is our website. So I want to get back to talking about how this changes membership and what that means to you potentially. So when we adopted the URISA banner, we had to come under their membership structure. And there are a bunch of different reasons for that. But essentially what it means is if you become a URISA International member, then you are automatically a member of Oregon URISA, and you have access to all of the things from URISA International, as well as everything down the line from your state to your local user group. We needed, though, to create a category for people that don't want to join at the national level, recognizing that for some people, paying $195 annually for a professional organization just isn't in the cards. And we wanted to make sure that regardless of your situation, you're able to access your local user groups and are able to participate at the state level. What we've talked about doing, and this isn't written into our bylaws quite yet, it's not been voted on. But what we would like to present is a Friends of URISA non-member membership, which I know doesn't make any sense, but it basically allows us to have a category of people who contribute to URISA and the goals that we are setting for ourselves regarding fundraising for scholarships to things like conferences, trainings, that kind of thing, without having this, $195 professional membership that you have to purchase through URISA in order to continue to participate in URISA. You don't even have to be a Friends of URISA, though. You can still participate in your local user group and be supported in the same way that you always have been without paying anything. But becoming a friend of URISA creates a way for people to contribute to our larger goals without that large dollar amount. Now, that said, if you do go and become an URISA International member, these are the categories that you'll be looking at. So for an individual professional, $195, individual young professional. And I want to stop here and say that the Board of Oregon URISA really struggled with adopting this membership category. Our feeling is that the term young professional is ageist, and it discriminates against people like myself who came to GIS later in life, but are just as enthusiastic and wanting to give back and get involved as the so-called young professionals. So I just want to say that I am working with URISA International to open up a little of that language. And so we are looking at, instead of young professionals, looking at a developing professionals category. So I'm just going to go ahead and call this developing professionals at $125. And that will be related more to how long you've been in your career rather than how old you are. An individual student, if you are currently in school, is only $20. So it really makes a lot of sense for students to join URISA International at that level while it is still so affordable. And in fact, it's even less expensive than the Friends of URISA category. And then there are different categories and different prices for organizations. So if you are within a government agency or an educational institution, you can access special rates for your whole department or a business partner. That's what the organization partner category is. So again, I just want to reiterate that, we do not anticipate that everyone who has been involved in Oregon URISA, who has been involved at the user group level, will make the decision to become a URISA member. However, I'd like to talk about some of the benefits of doing so, and I'll get to things a little later on. First, I wanted to talk about Oregon URISA. And why you should get involved with Oregon URISA. So there are board positions that come available on a rotating basis. And for me, this has been a wonderful opportunity to network with people across the state. So, I'm down here in Southern Oregon. I'm 15 minutes north of California. I don't always get up to Salem and Portland to attend, user groups up there to really network with people who have a lot of resources and are doing interesting things. Being on the board and being involved in my local user group has really allowed me that networking that I just wouldn't have otherwise. And there are always board positions or other volunteer opportunities available at the state chapter level. So I really encourage you to get in touch with me or Jennifer, or any board member, to see, if there are board positions coming available, which there will be in April. I think we have at least 2 at-large positions that are opening up, and you can be nominated or apply to run for those positions. I think probably the coolest thing, though, is these regional user group meetings and trainings, because these really bring together people in your area together in a way that you might not be able to interact with each other, whether you're a student, you work in different organizations, or you don't have the time to get together and just talk about GIS. For me, it's a huge relief to walk into a room of people who I don't have to explain what I do. It can be very exhausting to, constantly have to, well, yes, I make maps, but I make data and I make maps from data. You walk into a room of people who instantly understand you. And that's, one of the best parts of the user groups, is just getting to network with people close by who are doing things in the same realm and understand what you do for a living. We also do the annual GIS in Action Conference. And like Jennifer mentioned, I am co-chairing that this year. It's going to be in Portland, April 17th through the 19th. And you can find more information about GIS in Action at the urisa.org website. We have a call for abstracts open, which is sessions. So if you want to present on some cool work that you're doing, we would love to hear about it. Workshops, if you're interested in presenting a workshop, we have that open as well. And our map gallery, which is our annual contest for both in-print maps as well as any of your online work. You can submit to that as well. And that's a really fun way of getting your work out there and being able to add a little something to your CV, indicating that you made a really cool map and it was voted best in show. So these are some of the categories of the tracks that we'll be presenting at the conference. So photogrammetry and imagery advancements. If you want to come learn more about what's new in photogrammetry, Jimmy Schultz, who is the president of ASPRCS, if I didn't get that acronym right, don't tell him. But he is organizing this particular tract for us, and it's looking really cool. GIS collaboration. So this is going to be, you know, how we reach across our departments, how we reach across our organizations to work with everyone to collaborate, you know, GIS projects and data. Student emerging professionals and education. We're going to have all kinds of stuff on career development. I'm going to be there on a panel with several other GIS consultants talking about our different experiences becoming consultants, talking about the really key critical things that you need to know in order to be successful as a consultant, and some other topics as well. Public Works Essentials to Expert. I don't know what you guys will think of this, but I think asset management in GIS is like the wave of the future. If you are not sure where to go with your career, asset management is a huge and growing field. So we've got a whole track just devoted to that. Whoa. And that is my alarm to do something I'm not doing today. We have a technology showcase. So things that are really hot and new are fitted under our technology showcase, and that is still developing out. If you are interested, if you are a volunteer, if you're a student and you're interested in a volunteer opportunity, basically what happens is you volunteer, you come up, you volunteer for about 4 hours, and you get into the program for free. Our contact for that is the Oregon OIT, the new professor there, Sujin Lee. His information is there if you want to jot it down. I'll put it into chat later on as well. Again, please submit to the map gallery presentation, present a session or a workshop, and come and network, socialize, and learn. And last, I want to leave you with some thoughts about professional organizations. I see, you know, a lot of you out there, you know, are in different parts of your career. But one thing that I've learned moving through my career from student to intern to employee to employer is that I'm always having to iteratively design my career. And one of the things that helps me to do that is to stay connected to people who don't necessarily do what I do in GIS. It's really important for me to stay abreast of what's happening out there in the larger world so that I can think about how I want to guide my own education and training and career track. Even though I now work for myself, there are still things that I need to do to make sure that I stay focused on the things that I really, really love doing, the things that I'm good at doing, the things that I'm well connected to my clients to continue to do for them. And being part of a professional organization helps me to design my career in a way that is meaningful to me and still allows me to do the other things in my life that are important, like, you know, family and hobbies. So I focus not an insignificant amount of time on continuously redesigning my career to make sure that that I keep loving what I do, no matter what obstacles come up, no matter what, you know, market changes demand. Having a really intentional idea about how I want to proceed with my career helps me do that. Professional organizations, including at the state level or URISA and at the national level, URISA, provide formal mentee and mentor relationships. So if you are interested in being a mentee or you're interested in being a mentor, both levels of the organization provide a framework to connect you with someone who is a good fit for you, and to help you through the process of setting goals and achieving them together. I've been involved in it at the state level, and it's really a rewarding experience. You know, you think, well, what do you get out of being a mentor? Well, you learn a lot, because people who are just coming out of school have all kinds of really cool knowledge that you might not have, and they might be willing to share with you. Professional networking. So I was actually just looking at ArcUser for winter 2023, and right on the front page is networking is key to building a GIS career. On page 54, you can read about that. I participate in a women's entrepreneurial group here in Southern Oregon. And just last week, we were doing a workshop on preparing for networking opportunities. I'm going to admit this person from the waiting room. And one thing that that we were all talking about is how much networking professionally provides us with social connection. It's really not just for job opportunities and client opportunities. It really goes beyond that. One of the things that I think has been interesting recently in physical and mental health studies is the importance of human socializing to our overall well-being. And this is one way through professional networking that we can connect meaningfully with other people. And that just makes you a better professional. It makes you happier in your personal life. And it's something that I personally dedicate, again, not an insignificant amount of time to making sure that those networks, those connections with other people are healthy, and that I continue to have opportunities to meet new people and share what I do and learn from other people. So I really strongly recommend being part of a professional organization, not just because it's going to give you opportunities, but also because it's going to help you to be a healthier and more successful person in your career overall. It also is going to get more people coming in. I'll let them in. It also gives you an opportunity to give back to the profession, and whether or not you subscribe to some of, our larger GIS, ethical guiding documents, giving back to the profession is going to make you feel good. It's going to bring up the next generation of GIS professionals to take over the important work that established professionals are doing now. And it just feels good to be part of something, again, where you don't have to explain how you make maps. People just know and they understand. So I am Nikki Hart-Brinkley. This is my contact information. Please feel free to reach out to me if you have questions about URISA, about Oregon URISA, about the GIS in Action Conference. I'd be happy to answer any questions that I can, or get you to the person who can answer your questions. And let's see, we are at 2:47, so I actually talked longer than I thought I would. I'm going to go ahead and stop sharing.
Yes, thank you so much for enlightening us about what URISA is and the many levels. I know many of us here had questions about it, so good to get some answers today. With that, we have a few minutes for questions. If anyone in the room or online has any questions, we'll just open the floor for that.
I'd like to make a comment first. So as far as figuring out how SCUG and or URISA We'll be interfacing going forward since we're reconvening the group. That will be a major topic of discussion in our next meeting. That will be sometime in early. Thereabouts, date to be determined. So if you have questions around that part, I'll try and put those down so that we can bring those up.
That's a very good point. Thank you.
Yeah, and definitely feel free to reach out to myself or anyone else on the board. One of the things that we'll be aiming to do in the coming year is to kind of codify some of the support around user groups, providing guidance and suggestions. There have been some long established groups that, have continued to put on amazing programs even through COVID. Mine is not one of them. I have been a little lax, but there are other user group leaders who really have been just model user group leaders. And so we can definitely talk about how the board can support you through brushing off your user group and getting things back up and running.
Yeah, that'd be great. Any other questions from the group? Think not. Well, thank you again so much for taking the time to speak to us today.
Thank you.
Thank you. We're a few minutes ahead of schedule if everyone wants to proceed on to our next speaker. And then after that, we can take a short break again. I'm surveying visually the room. It looks good. Online, unless there's any major objections. Give you a moment to find those mute buttons. All right. Well, I saw our next speakers have jumped on already, so I will go ahead and introduce them. Next up, we have what is open topography? We have Dr. Emily Zawacki, who is a postdoctoral research scholar at Arizona State University, working on education, outreach, and communication activities for open topography. And she is joined by her colleague, Chelsea Scott. So I will turn it over to you two.
All right, thank you for the introduction. Let me make sure we can share our screen okay.
Yep, it's just come through.
Okay, all looks good on everyone else's end?
Yes.
Okay, great. Well, as the introduction said, my name is Emily Zawacki, and I'm joined by my colleague, Dr. Chelsea Scott. We're going to talk about open topography and how we work to enable access to high-resolution topography. So I'm first going to start off the talk by giving a general overview and introduction to open topography and what we do if you're not familiar with us. Then I'm going to talk about how you can access data and the myriad of resources on open topography. And then I'm going to hand it over to Chelsea at the end, who's going to talk about some big data applications and our work with statewide vertical topographic differencing. So just as a fun image you can see on this slide, we have a point cloud of the Oregon State Capitol, and this is viewed on the Potri Point Cloud Viewer on open topography. Let's see, might be a little slow going. Okay, there we go. On to the next one. So what is open topography if you're not familiar with us? Well, our goal is to democratize online access to high resolution topography. So we provide access to high resolution topographic data that's collected via LiDAR, photogrammetry, and also satellite platforms. And we have on-demand processing tools that can generate derived data products and visualizations. So everything can be found and is available via our website, that is at opentopography.org. So our Open Topography team, we're led by a small but mighty team of geospatial, cyber infrastructure, and education experts that are housed at 3 different institutions. So we're at between the San Diego Supercomputer Center, Arizona State University, where both Chelsea and myself are at, and then also EarthScope Consortium, which was formerly UNAVCO. So the Open Topography facility itself is at the San Diego Supercomputer Center. So we're able to have all these supercomputers do all this heavy lifting with the vast amounts of topographic data available. Open Topography was founded back in 2009, so we've been around for over a decade at this point. And our main source of funding is via the U.S. National Science Foundation. So in terms of all of what Open Topography does, so we provide services for hosting, management, and distribution of high-resolution topographic data. So we host data that's both for academic collections. We also host LiDAR data covering New Zealand. We host the state of Indiana's LiDAR data. And we also host a lot of Dogami LiDAR data in Oregon. And we make it easy for everyone to access and use this LiDAR data. As well, we also provide direct access to USGS 3D elevation program and NOAA LiDAR datasets, although these 2 types of datasets are currently in limited access to educators. In addition to the data itself, what we are kind of big bonus bread and butter is that we provide web-based processing tools to compute derived data products and visualizations. So we'll compute your digital elevation model, hillshade, slope, Google Earth visualizations from the topographic data itself. In addition to all the data side, we also have education and training resources in the use of high-resolution topography. So this map is showing, at least based in the US, the high-resolution topographic data that's available on Open Topography. In total, through the data that we host or provide access to, it's over 60 trillion points from LiDAR and photogrammetry. So on this map, everything that is within a red polygon is Open Topography data. And this is data that is completely open for anybody to access and use all of our processing tools on. All of the green shows the USGS 3D data, and the blue shows the NOAA data, which is quite impressive coverage over the US. And currently, this data is in limited access to educators, but we are working on opening a paid subscription model in the future where everybody can access this data through our easy-to-use interface and compute-derived products. But in addition to all of this high-resolution topographic data, we also provide access to 12 different global and regional topographic data sets, such as SRTM, other USGS raster data sets. And we also have a lot of heavy use from these global data sets, in addition to the high-resolution topography. So this is just some example of the kind of topographic data and derivatives you can get from Open Topography. This is an example using the Indianapolis Motor Speedway. So you have the point cloud itself shown in our 3D point cloud viewer. You can have another format looking at it, the rasters, such as shown here, a hillshade of the Motor Speedway. And then you can also on Open Topography compute your vectors or contours showing lines of elevation. So Open Topography has a large suite of data services. These are all on-demand processing tools, and we'll create these products for you from the topographic data. So on Open Topography, you can generate a digital elevation model, topographic hillshades. You can compute canopy height models, generate contour lines. We also have 3D visualizations, and some extra cool tools we have are both vertical differencing and 3D differencing. And Chelsea will talk a little bit about vertical differencing later, where we can look at comparisons between repeat LiDAR data coverage. And then as well, we can also compute hydrology tools or TOWDEM products. And in particular, the 3D differencing and hydrology tools are pretty heavy computes. So that's why, thankfully, everything is run at the San Diego Supercomputer Center. We have these great supercomputing resources to compute all of these products. So I'm going to go into a little bit of an overview now of if you want to go on Open Topography and access data and download any of these products. So we have a nice web-based portal that shows a map with coverage of all of our topographic data. So here we're zoomed in on Oregon and Southern Washington. And so this map on the left is showing all of the data sets, which again in green is the USGS data and blue is in NOAA. And those currently still are restricted to educators, but shown in the other inset here, everything that is in red is data that everyone can access on Open Topography. So a lot of these data sets shown here are Dogami LiDAR, which is a pretty good coverage, especially along the coasts. And so once you kind of select a region, you just draw a box around the area that you're interested in. And it will come up with a list of all of the LiDAR data sets that are within your selected region that you can choose from. And as well, you can also toggle between here and choose any of the global or regional digital elevation models. So I'm going to walk through a little example of how if you want to get some data from Mount Hood. So again, with our kind of easy to use portal, you can zoom in on exactly the area that you'd like your data from, and you simply draw a bounding box around the area. And you can see the red is showing exactly where the bounds of the available data are. And then if you're using a point cloud data, you would then choose your return classification, whether you're interested just in the ground points in a digital train model, or if you want to look at all the points and see a digital surface model. And then we have a whole ways you can customize your job. So you can either, select and use our presets on Open Topography, or you can choose exactly which type of products you'd like to generate and how you'd like them done. So you can choose the format that you'd like your point cloud data downloaded in. We have that kind of default to LAZ, but we do have some other options. And then you can also choose some specifications for generating your digital elevation model. So for example, here you can change the default grid resolution. And this data set is default to 6 feet resolution, but you can change that as needed. And you can change the format types. And then you can also choose to generate a whole bunch of different raster visualizations. So this is where you can click a box to select to also generate a hillshade, a color relief, color hillshade, many more. And when you select it, it'll also give you options to compute Google Earth KMZ files for all of these visualization types. You can also select to generate a 3D point cloud visualization. And then you can expand to generate contours. You can specify exactly the contour interval that you'd like to generate. And then lastly, if you're kind of more into heavy duty hydrology, you can choose to compute TOWDEM products for hydrology terrain analyses. So once you've made all these specifications, these jobs are run on demand at the San Diego Supercomputer Center. So if you're working on a laptop, it doesn't have to do any heavy lifting. It doesn't have to do any supercomputing. You're essentially going to have a supercomputer in your hands when this is sent off to San Diego. And so you're going to get an email when everything is finished processing, and you'll get a page that shows all of the results. So you can see running this from Mount Hood. It processed over 200 million points in around 20 minutes. So this is good if you want to kind of run this over a coffee break, and it's going to produce a whole bunch of other visualization and derived products during this time. So you'll have the option, all you do is click to download all the data. And so you can download these DEM and visualization products in GIS software to further work with them. This is where you'll be able to click on and view your 3D point cloud viewer. And then below that, it will show all of the other visualization products. So this is great if you want some fun images that are automatically generated. And this is where you can also choose to generate a Google Earth KMZ file, and you can open it in Google Earth and explore it there. So this is now showing what an example of our 3D point cloud viewer is. So this is called the Potri viewer. So this is looking at that Mount Hood job that I processed using this. So you can generate files that can be point cloud files that can be shown in this viewer. And there's also tools where you can change the type of visualization. So this is shown with elevation. You can also make measurements. And we have other resources on our website for using this point cloud viewer. But if you want to try afterwards to run your own data sets and look at it in the point cloud viewer, that's always super fun to do. And then here are some more examples of visualization products that can be computed. So this here is a hillshade and DEM of Mount Hood. So this is from the visualization products that I then brought into GIS. And then this is just looking at them in a fun 3D view. So there's a lot you can do depending on your level of familiarity with different softwares, whether you want to kind of bring things into GIS and do a whole bunch of different things with them. Versus on this end, this is an example of Crater Lake brought into Google Earth imagery. So this is taking the option to generate a colored hillshade, and then we create a KMZ file, and then you can bring it into Google Earth and do a whole bunch of navigation and exploration in there. And so that's everything that can be done with the high resolution topography available, but we also provide access to lots of global and regional topographic data. This includes SRTM data, NASA DEM, ALOS World 3D, Copernicus, and then within the US, a number of USGS raster products. So this kind of follows the same format where you can navigate on our web-based interface and select your area of interest. And from that, you can generate a digital elevation model, any of the raster visualizations, and then also the hydrology products. And then so this is showing an example of some of the data, derived data products using our global topographic data. So here you can see a colored hillshade of Mount Fuji that we've brought into Google Earth. And then this here is Mount Etna with contours overlaying. So Mount Fuji was created using SRTM data, and then Mount Etna was created with the Continental Europe digital terrain model. So even if we have areas that don't have open access, high resolution topographic coverage, we do have all this global and regional topographic data available that has available many of the same on-demand processing tools for visualizations and DEM creation to further use in GIS software. Now, that was all based using our web-based portal to access data, but we also provide API and bulk access to our global data sets. So if you go on Open Topography and create a free account, you can get an API key. And using your API key, you can then access all of these listed global data sets through that means. And then as well, these data sets are cloud optimized GeoTIFFs or COGs, which allows for easy bulk access of all of these global data sets. And so at Open Topography, we're always very excited to hear of the really diverse use cases of our topographic data and derived processing tools and products. So of course, we facilitate a lot of earth science research and many publications, but there's also lots of users who will use the topographic data for video game development or for creating 3D worlds in Blender. Some people make personal maps for, such as for their family ranch, or using contours to create orienteering maps, or many applications for 3D printing, such as at the Indiana School for the Blind. So there's any use case you can think of for Open Topography. There's tons of cool things that you can do. And so that kind of covers a lot of the data side of what we offer, but we also provide education and training related to topographic data. So we offer short courses on LiDAR technology, data processing and analysis, and applications. So we've run short courses at a number of national conferences. We've also run them for state agencies, and we're always happy to come and give customized short courses on any topics of interest. You can find all of our short course material archived on our website. All of this education and training you'll be able to find under the Learn section of our website. We're also soon going to be starting a spring webinar series beginning on March 15th. These are going to be weekly webinars that are going to start by giving an introduction to open topography and then talking more about topographic data and then other applications such as the hydrology tools. So if you go to the main page on our website, you'll be able to find more information on that, and as well as registering for all of our webinars. We also have a YouTube channel where we have a myriad of video tutorials specifically on open topography resources, but then also related tools such as MATLAB and Cloud Compare. And on our website, we also have some ready-to-use classroom activities for educators, and then also just some really cool pre-generated visualization products of really neat landforms. As part of this, we also have a suite of Jupyter notebooks and also Python packages. So one of our really cool Python packages is River REM, and this automatically will generate a river relative elevation model, which are these beautiful visualizations highlighting rivers and their floodplains. One of our notebooks, it goes over the bulk access to COGS. And so these are also able to access through the Learn section on open topography. And this is really great if you'd like to do some kind of self-paced learning using Jupyter notebooks or Python. And then as well, if you're interested in 3D printing at all, we have a full web page and video tutorial for how to access and download topographic data from our website, and pretty easily convert that into a file that you can use for 3D printing. So it's just a kind of quick plug-in in GIS software. And this is a nice visual representation of what a 3D printed model of Mount Hood would look like. We also have a number of pre-made 3D printing files on our website that's under our open landform catalog. So this is another really cool application of all of the topography data that we have. You can 3D print it out and hold it in your hands. And with this, I'm now going to hand it over to Chelsea Scott, who's going to talk about our topographic differencing work.
Thank you, Emily. So at Open Topography, we're also interested in pushing the boundary of how we can process large-scale topography data sets. So we recently completed a project of statewide topographic differencing for the full state of Indiana. So in that figure on the right, you can see an example of these results. On the very right, you see the topographic differencing results, where red is erosion and blue is deposition along this river in Indiana. And so we created these maps of vertical change over the full state of Indiana. So I'll spend the next few slides discussing this project. And if you're interested, you can learn more in Remote Sensing publication, which is an open access publication. So on the next slide, shows more information about our project. So we were really motivated to figure out how to do large-scale processing of the USGS 3-depth topography. And on the surface processing side, we're also just interested in what a decade of change looks like over an area the size of Indiana. So many people ask, well, why did you pick Indiana? So first, there's 2 statewide LiDAR data sets that were acquired about a decade apart. And these are really useful for this project of statewide topographic differencing. And second, we anticipated a variety of interesting examples of change due to Indiana's varied land use, from the urban areas, the agriculture, the forests, the coastlines, as you can see here. And third, open topography has been in about a decade-long data hosting partnership with the state of Indiana. And so this project allowed us to further that relationship with Indiana. So the next slide demonstrates on the technical side of how vertical topographic differencing works. So to do this, we need two topographic data sets. The first one in technical language can be called the compare or the pre. And that the point cloud here is shown in blue. And our first step is to take that point cloud and then produce a raster digital elevation model. And we do the same with the later data set, which can also be called the post or reference topography. You'll see that there's many more pink points than blue points. And this reflects the fact that LiDAR data sets have often increased in quality over time. And so we see both more points and higher quality data sets, or points for that second data set. And then vertical differencing is the raster subtraction of these two data sets. So you can see on the right, that example of the change map shown in red and blue. And the red represents areas that have gone down. So if this is along a river, that would be erosion. And the blue represents areas that have gone up. So again, along a river, that would be deposition. On the next slide, I go over some of the challenges in performing this statewide topographic differencing. So Indiana is 94,000 kilometers or square kilometers in size. And so the differencing workflow must be almost completely automatic and have very little input from the user, from me, to get this done. The final products that we generated are about 4 terabytes. So this brings in the question of how do we store these data and how can we visualize the results efficiently? We needed to integrate the differencing workflow with our high performance computing resources. For example, processing full statewide differencing on a typical workstation would take about a year, and we just did not have this time to wait. And we needed to ensure sufficient memory for the intermediate calculations. And so this essentially required being careful of the size of the point cloud and raster data sets for different parts of the differencing. During the project, we thought about what are the sources of noise, and second, should we even correct the sources of noise at the statewide scale? I'll show you a figure later that shows some of these noise sources. And then finally, we were interested in what's the most effective way to visualize and communicate the results. So the next slide shows the results of the Indiana statewide topographic differencing. So on the left, you see the digital terrain model, and on the right, you see the digital surface model. And there's multiple different processes active at this scale that generate topographic change. Some of the most prominent signals are related to rivers and the surrounding riparian zones. So for example, you can see the signals from the Wabash and the White River, which cross the state. They create those quite interesting patterns. There's also signal from vegetation changes. For example, in the digital surface model, the southern part of Indiana, you can see that sharp change from purple to red, and that reflects different seasons of data acquisition. There's also prominent, quite high amplitude, spatially localized signals from quarries and mining, For example, you can see multiple examples of quarries in the southwestern part of Indiana. And then finally, one of the probably the most prominent signal that you see is from flight alignment errors. So if you look at the digital terrain model, there's a variety of both north-south and east-west, red and blue patterns. And those reflect these flight alignment errors that are largely from the older data set in the topographic differencing. And if you'd like to review these results zoomed in for the full state of Indiana, you can go to our browsable map at portal.opentopography.org/Indiana. So I'll now show you a few examples zoomed in. So these both examples look at new developments and construction in Indianapolis. In the top example, we see the construction of a new suburban development. And in the bottom example, we see a development of a cloverleaf freeway, as well as some gentle bending of the freeway approaching that cloverleaf intersection. So the next example shows what I think is probably the coolest geologic feature in Indiana, and these are sinkholes. So these sinkholes, as you can see on the left, produce this golf ball-like pattern in the topography over the state. And then on the right shows vertical change. So you can see that the red, those show new sinkholes over the approximate decade between the both data set acquisitions, and then the blue show sinkholes that were filled in. So this is, I think, just a very interesting way to view this geologic hazard in Indiana. So looking forward, about 1/3 of the lower 48 of the US is covered by repeat LiDAR topography. So this presents really a big opportunity to characterize change from the natural and anthropogenic landscape. And there's many applications, for example, looking at biomass change, coastal change, hazards such as flooding, landslides, sinkholes, and urban development. One of the challenges that at Open Topography we discuss is that it becomes challenging and really prohibitively time intensive to analyze these large data sets. And so we're looking to develop approaches like machine learning.
Right, so then I'll kind of wrap everything up, kind of what we hope you'll be able to take away. So Open Topography provides easy access to high resolution and also global and regional topographic data and derived products that are great even if you are a very experienced GIS user, to even if you're newer. And in addition to this data, we're also working to grow access pathways to USGS 3DIP and NOAA data, hopefully planning a subscription model in the future so everybody can access that through our portal and use our on-demand processing tools. We as well have a large suite of education and training resources related to topography for self-paced learning. And then, as Chelsea discussed, these state and national scale data sets really present a huge opportunity in advancing processing and analysis of this topographic data. Let's see, again, PowerPoint has gone a little slow. But we'd really like to thank you for having us talk today. And again, you can find Open Topography online at opentopography.org. And for any questions or contact at any time, our email is info@opentopography.org.
Wow, thank you so much, you two. We really appreciate it. That's such an amazing online open resource that we can all access to do crazy large projects. So that's fantastic. I'm going to open to the group for questions. You have one in the room?
So, in the open topography part with all the data coming from Dogami and 3DEP, how long does it take for new data to get uploaded into your system? A lot of the South Coast LiDAR from 2009, I believe it was, or 2008, was reflown in 2020 and 2021, and a whole bunch of new areas were added. When do you know if that data will be added to your open topography workflows?
Let's see, Chelsea, would you know how to best address?
Yes, so the 3DEP data are available on open topography a few weeks after they're available from the national lab. And yeah.
All right, thank you.
Any questions from the room or anybody online? You guys do have an upcoming spring workshop, if I'm not mistaken, a training workshop, and that's posted on your website as well.
Yeah, so this is our spring webinar series. They're going to be held weekly starting on March 15th. And so on our main website page, you'll be able to see the post all about oh yes, thank you for Chelsea putting that in the chat. That has the full schedule and topics of all of these webinars, and it includes a link where you can register for these webinars. And then if you're not able to make any of these webinars live, all of the recordings will be posted on the Open Topography YouTube page.
The webinars are free to attend, but you do need to sign up in advance to get the Zoom link and so forth.
So two questions. Being coastal, the NOAA data set might be of interest to folks here, or the ones that, or others that are more coastal based. As they are now just available to educators, is there a possibility if someone has interest in those data sets that they can contact someone for a specific use?
So we are looking at two approaches to open those data sets to a much broader community. So right now, if anyone is interested in sponsoring a coastal NOAA data set to become open to anyone in the same way that all those red data sets are open, then they can contact us at info@opentopography.org, and we can work with you to make those data sets available. If someone is interested in getting a subscription access to those data sets for their use, whether that's personal or commercial, then we suggest you wait, as we are looking at soon opening a paid subscription service to all of the NOAA and 3DEP data sets.
Thank you. Could you put that contact in the chat?
Yes.
Thank you. And also, we noticed that at least I noticed, sure other people did too, when you showed the repeat LiDAR map, Oregon was pretty sparsely represented there. Is that more of is that going to be changed soon? Is that something that is a current limitation, and we don't know if it's going to be filled in soon? What's the status of that?
So through the 3DEP project, the USGS is working to get at least one acquisition of everywhere in the US within the next couple of years. And then I've heard that they're looking at, in the next following decade, getting that second data set acquisition. So that would then give topographic differencing capabilities to the entire US.
Thank you.
Wow. That'd be a big project.
Yeah.
Any other questions from the room or anybody online? If not, thank you again to our speakers. We really appreciate you taking the time to let us know about the many options from your organization.
Thank you.
Yes.
We are a little ahead of schedule. I say we take a 5-minute break and then we'll come back for our final speaker. So I'll see everyone in about 5 minutes. We're now re-recording. So I'm just gonna jump into our last 2 folks today. They're gonna do ESRI has sent 2 representatives here today to present on imagery solutions. They're gonna do drone to map and site scan. We have here John Sherrard, who's a GIS solutions engineer with ESRI and works as part of the team supporting customers in the Pacific Northwest. He's been working in the GIS field for 35 years. He concentrates on GIS solutions for local government, 3D GIS, geodesign, land records, transportation, and you're a graduate from the Geoscience program at Oregon State University. So fellow Beavs. Also here presenting, we have Brian Richardson, who is also a solution engineer and has a background in imagery. So I will turn it over to you to.
Very nice. This new version of Zoom, I'm not able to alt tab, so go between the screen sharing here. Okay, my name is Ryan Richardson, and I'm here from ESRI. I work out of this the Olympia, Washington office. I'm on a state local government team, and I'm a solution engineer. And what a solution engineer does is working with state and local government. We do a little bit of everything, but I'm here to talk about one of my very favorite passions, which is drone imagery and imagery solutions, and it's my favorite part of my job. So today I'm going to cover some differences between our solution stack within the ArcGIS suite of software, particularly talking about site scan and drone to map. And I couldn't have been set up better from the other presenters. I've been going back and forth about presenting drone imagery for a couple of weeks now. And it's such a deep topic that on the surface, we can get through it, you know, how things work pretty quickly. But Jake and everybody else has done such a great job in laying the groundwork for how this stuff works that I think getting into some of how our software works, hopefully everybody's able to understand things pretty well. So drone imagery solutions, ESRI has 2 different drone mapping pieces of software, and a lot of the questions I get as a solution engineer, what are the differences between the 2? And toward the end of the presentation, I'm going to demo both of them so everybody can get the difference between 2. But what I want to bring everybody's attention to is imagery as a comprehensive solution within the ArcGIS stack of software. We're talking here about the drone mapping and data production part of the solution, but the solution is a circular process. And the really great thing about drone imagery is sometimes it's only a piece of your analysis. Drone imagery can be used in combination with aerial imagery and satellite imagery. And as everybody knows, when we're talking about GIS, we can manage layers of data. In drone imagery, you have a lot more control over what you want to capture. So we start off in the mapping and data production part of the gear here, and we can create 2D and 3D mapping software. We've talked a lot today about point clouds and orthomosaics. I'm going to get into some examples of those later in the presentation. I go along just giving because I get excited about it. So creating your own data and then managing your own data, which is something that is I've been teaching drone mapping for a few years, and I am the worst culprit for managing my own data. You start working with drone imagery. Each of your missions, sometimes it's hundreds of images. And so those images add up and add up. So management of imagery is one really, can be a really challenging part of an imagery solution. And within the software, if we're talking about SiteScan, all of your imagery is managed in the cloud. You don't have to worry about scaling. You don't have to worry about where it lives. It's all in the cloud. I'll get into how that works later. You can manage things if you've got an enterprise. If you've got ArcGIS Enterprise, you can manage things with your imagery with the imagery server. And you can also, if you're using a desktop program like Drone to Map, and if you're maybe a smaller shop, you can manage your data on external hard drives or your own server space, even on your desktop. And then we go to the analysis process, which drone imagery, I've come to learn pretty quickly, even though it's been around a while. We're really in our infancy of how our data is collected and how it's analyzed. And I've been working a bit with folks, particularly in emergency management, and talking. I was recently in a conversation with a former firefighter who started the drone orthographic program through the Austin, Texas Fire Department. And he'd been in some big fires and ran imagery in their EOC. And I'm learning, and it's kind of my own background too, how I got into GIS was through drone mapping. And so there are a lot of times with drone mapping, you've got people in the field who are creating the data. They're sharing it to a GIS analyst, and then the information is being visualized within apps and web maps and so on and so forth, the stakeholders and decision makers. And we're in this transition period where a lot of the, particularly firefighters who are creating the maps in the field, are learning how to do some analysis, and we're building this new GIS community, which is pretty neat. While coming together as a community, and sometimes the people in the field are starting to be able to do some of the analysis, and it's not such a cryptic thing anymore. But after the analysis is completed, and we've seen a bunch of different use cases today, which is very exciting. The analysis is shared with stakeholders and decision makers, and shared in online apps, and particularly and within the ArcGIS stack. We can share it in web maps, we can share it in Experience Builder, we can share it through Story Map, what I'm sharing in today. And then the data comes back to the data management, and we can have a circular process. So this more data can be created and analyzed and shared, and so this data can continue to be used, and it's not just used once. When I first started to make my background is in imagery and professional photo and video, and I got a drone and I made my first map. And I said to myself, gosh, this is like the coolest thing I've ever done, but what do I do with it? And then I discovered GIS, and I was like, wow, this is what you can do with it. You could push, at least we've seen many use cases today alone, how you can use this data. And to me, it's a really exciting. And I've also shared the story map in the chat before I forget, my email is in the chat as well. If anybody has any questions after the presentation, I'm happy to answer them. You can get a hold of me later on. I'm happy to answer questions. So what is the drone imagery as a system? In the ArcGIS system, drone imagery, it can be produced in two ways. Any imagery created with a drone, created with even third-party software, can be imported. It can be ingested into SiteScan or Drone to Map in process. SiteScan is our end-to-end cloud processing solution. With that being said, SiteScan through ArcGIS Flight, which is an iOS app, you can create missions, fly missions to create 2D orthomosaics, 3D orthomosaics, and everything is processed in the cloud, and all of your imagery is stored in the cloud. Drone to Map is a desktop solution which looks very similar to ArcGIS Pro. You can fly the mission. You can fly a mission with SiteScan or with ArcGIS Flight and process it in ArcGIS Pro. You can fly a mission with DJI software, whatever drone you're flying with, and you can process that in Drone to Map. And then you can share directly into Pro as a Pro package. You can share to ArcGIS Online. You can share to your portal. Whatever your workflow is, you can work through Drone to Map as a desktop application. With a few thinking about ArcGIS Flight, there's a few caveats with ArcGIS Flight. ArcGIS Flight does not work. The flight part of the software, you can't fly every drone out there. A lot of drones you can fly. I've got a short little demo about how the flight software works. It works with most DJI drones. The Mavic 2 Pro being probably the drone that most users fly. The Phantom 4 Pro, which is the tried and true orthographic mapping drone, works with the original Mavic and the Matrice. There's out of Woodinville, there's a company called let me go back to this here. FreeFly, and FreeFly makes the Astro, and FreeFly is a new partner with ESRI, and they've made the Astro Map, which is a really interesting drone. I have not flown it yet, but one really interesting about this drone is you can interchange your payload, and so you can fly a DSLR, you can fly thermal cameras, you can fly multispectral cameras, all with one drone, and this drone does fly. It's also an American-made drone, so this drone does fly within the ArcGIS within the ArcGIS Flight app. Use cases, which we've gone over a lot of use cases today, which is pretty exciting. Let me move my people over here. There's several different use cases. And I've created that there's hyperlinks to blog articles under all these pictures. But ecoscience is one big use of drone imagery. We saw that with the drone imagery solutions in Colorado that Jake was talking about. Historical preservation. There's this particular article is about mapping trash and waterways. I believe it's in California. Public works departments use drone imagery quite often for environmental monitoring, infrastructure management, disaster response, asset management, urban planning, so on and so forth. Another real big one is emergency management, public safety, and law enforcement. As we know, here in the Northwest and in California, wildfires are a big use of drones in the summertime. They can be used for change detection, and oftentimes, it may be hard to get an airplane in the air to get aerial imagery, whereas drones can fly. We don't have to put people in an airplane and risk anybody's safety. Fixed wing drones can cover a lot more ground, and battery life is extending. Fire service is a big use of drones. Many of you may remember a few years ago there was a condo collapse in Florida, and I think there was 3 or 4 drone pilots on staff at the scene for quite a long time, and they were creating 3 or 4 3D models a day of the collapse. And they were using it initially to plan rescue, to figure out how to get people out. And then these 3D meshes were used to reconstruct the building to figure out how this collapse happened. And each of these drones, we'll get into how some of this process works a little bit later in the presentation. But you could create these 3D models in a matter of a couple of an hour or two, depending on how fast you could process your imagery. It was really exciting to hear of the uses of archaeology with drones and some of the presentations earlier today. I think archaeology is a place where drone imagery is often overlooked. And it's such it's a fantastic way to reconstruct archaeological sites where students won't have to interact with the site. We can use remote sensing to recreate 3D models of these scenes. We can look at digital surface and terrain models to see what the ground looks like. And reconstruct, it was amazing seeing the work done in the mines in Colorado. Spent some time living in Colorado with all those mines, and really neat seeing 3D models of those. I'm a little bit jealous. I think they were, that looks like such fun projects to work on. Inspections are another huge use case with drones. We can get drones to places where it's very dangerous to get people. In this particular case, power plant, bridge inspections, dam inspections. And we can build 3D models with drone imagery. When we use GPS and ground control points, we can get centimeter level accuracy by using ground control points. So inspections of these sites can be really accurate, and these models can be shared out and visualized with multiple different apps. Digital twins, cities are using digital twins with multi-mission maps where drones can be used to fly several missions and then stitch together in one big map. There's a great map of it's a city in Austria. I can't remember the name of the city, but they did a map of the whole city and did a 3D model. It's fantastic. And there's another one that we did, our imagery team did of Mountain Village, Colorado, in Telluride, Colorado. They mapped the entire ski resort. It's really pretty interesting. Construction's another big one. We can do volumetric measurements with drone map and site scan. We can measure. We can do surface measuring, like we can do RTS Pro and RTS Online. And then construction sites often use orthographic mapping for change detection, so they can map and monitor the progress of change over time. Agriculture is another big one. We can fly multispectral drones and create DPI maps to analyze crop yields, disease, and again, you can use GPS accuracy to really pinpoint where disease might be in a field. Natural resources, we heard a lot about how natural resources uses remote sensing today to analyze waterways and forests, and drone imagery is being used to count animals, in particular animal habitats. Deep learning is coming online to be able to find some of these, use imagery and using deep learning to map seal populations without even having to be there and to count everything within your imagery. Urban planning is another one that I just mentioned. Are all uses among many more of drones. So we got in a little bit earlier today. Oops, actually. So a lot of 3D imagery today. This is a 3D model that I did of the Olympia Brew House a few years ago for the city of Tumwater, Washington. And I'll get into how we did this a little bit later. But imagery can be used. We saw a lot of zooming in and out of your mesh. We're on for inspection purposes. This was a historical site that the city of Tumwater spent a lot of time restoring, and it's the old Olympia Tower. This is a fun project. So how do you do this? We saw how to create these orthomosaics a little bit earlier today. And I don't know how many people have had the opportunity to fly and create an orthomosaic in the field. But I'll do a little bit of rinse and repeat of the process. There's several different ways and several different mission plans you can use to create imagery in the field. The traditional way is the ox plow or lawnmower method, where you fly your drone in a lawnmower pattern back and forth, and you take a series of images that overlap, usually around 70% on your forward overlap and around 60% on your side overlap. And then software uses the GPS location within the drone and the data within each image, each overlap image, to stitch the imagery together, and to get your mosaic map. In a perfect world, this works easy, but then when you add in complications like flying over water and reflecting over water, sometimes creating these maps can be kind of challenging. Doing forest studies over largely forested areas like we have here in Oregon and Washington. Sometimes we need to use methods like the crosshatch pattern, which is just taking flying the ox plow lawnmower pattern and then crosshatching it, so you get imagery from even more angles, and so you're able to capture these tree canopies that sometimes the software has a bit of a tough time calibrating where all the leaves and all the branches are within the image. Creating orthomosaic images, typically the way that the lawnmower pattern and crosshatch pattern, we use a nadir camera angle, means the camera is pointed straight down. To do 3D models, the camera is pointed at an oblique angle, somewhere between 20 and 45 degrees, depending on what your subject matter is. And then you, for the best results, doing several orbits. You can get the key is to get the imagery of more surfaces, the better, in order to get an accurate 3D model. And it was really neat seeing the presentation earlier of creating models on the ground using a DSLR and showing how moving around an object, you don't have to use a drone to process this image and to create this imagery. You can create this remotely sensed imagery with a handheld DSLR and stitch it as well. As long as you've got good overlap, and there's definitely some trial and error. It sometimes looks a lot easier than it is. So I want to get in for the next 10 or so minutes to talking about 10 or 15 minutes and talking about drone to map. I've shared the story map with everybody, kind of with some cliff notes. Just a way to get you started. Of course, the software can get really deep, and I'm gonna touch on the software at the 10,000 foot level and just get everybody started. But for the most part, flying drone imagery, getting good overlap, and making sure your images are exposed properly is the first step to getting good usable drone imagery. The time of year is really important too, the time of day. Right now, if we look outside, we've got really long sun angles, which makes for beautiful photography. Maybe not. Sometimes it's pretty tough for orthographic mapping, because having these long shadows and long dark areas, the software can oftentimes get confused, and processing can get a bit skewed. Sometimes you don't have a choice. Sometimes you've got to go out and fly because time is of the essence, and you've got to go fly. But for the most part, getting well exposed images, planning out your process is the first step to creating successful orthographic images. When I get into the site scan demo later on in the talk here, I have a story about really tough project we worked on a couple of weeks ago. Just getting the drone off the ground can be challenging sometimes. I'm going to switch over here to drone map and go over how to create imagery within the software. The first in my story map, the first slide that you saw there was the ingestion slide. When you come back with your imagery, you can ingest a folder, you can ingest or you can ingest a series of imagery. You set up a project just as you would in ArcGIS Pro. You can set it up locally. It does work on an external hard drive, but imagery does not process if you're using something like OneDrive. You can't have your images in OneDrive and then process them in Drone to Map. I wish you could, but it doesn't like that. But it does work. It does work pretty well if you're saving to an external hard drive, because this imagery, especially if you've got a fairly high resolution drone, can really take up a lot of space quickly. So for those of you who my slide of Zoom over desktop here so I can work. So those of you who have used ArcGIS Pro and migrated to Pro recognize the ribbon structure of probably recognize this ribbon structure very well. It's very similar to ArcGIS Pro. You can work just as you work with Pro, connecting folders. You can connect to ArcGIS Online. You can connect to your portal and work doing light analysis within Drone to Map, and then of course for much deeper analysis, you can export to Pro. When you bring your imagery into Drone to Map, you will see your flight pattern, and you'll see each image is presented in your map here. And then all of these images will be stitched together to create your orthomosaic project or products. I've got a few more layers here because I'm not going to process this on site, because I think this will take 20 or 25 minutes to process. So I took the liberty of processing it ahead of time. But typically what I do when I come back and I'm doing my initial process, oftentimes you're working a series of steps when you're working on a project. I typically process in my processing options here, which is up here at the top of the ribbon. I typically process things with the default settings. The default settings will process relatively quickly, and it'll let me know let me know how each image is calibrated. It will give me a good basis for what I have to work with, and you can always go reprocess your imagery. And I just don't have time to get too deep into these menus today. But the more imagery you process and the more complicated imagery you process, typically with tree canopies and water, oftentimes you need to tweak your processing a little bit, so it will process the images a little bit deeper than a base level process. It used to be a checkbox in the old version. It would say to run dense, and if you would uncheck that, it would run a faster cycle, so you could just see what you've got. So the first thing that happens when your imagery is processed is each of these images is calibrated, meaning the processor goes through and makes sure that everything is going to fit within the parameters so it can be used in the map. All calibrated imagery will show up in blue. If you've got imagery that won't calibrate, for instance, what happens with dense tree cover is you'll get an orange dot. And sometimes it's a matter of just tweaking your process. And then sometimes it's a matter of going back and flying a crosshatch pattern or creating imagery a little bit differently. Sometimes flying higher is better. But it's a bit of trial and error to get accurate maps. Sometimes it can be very challenging. So once your imagery is processed, you will end up with some imagery products. So I'm going to open up this here. And when I process my imagery, oops, just show you here. My data products are, I created an image collection, an orthomosaic, an ESM, and a digital terrain model. all within my, all within my 2D processing functions. This particular, this was an ecological study for some habitat restoration. And because this is just a marsh, we didn't run a 3D model of it. So we flew nadir, and we didn't do any angles. So I didn't run the 3D model. 3D modeling will take a lot longer to run. So I didn't run it for this particular job. And you can see the three products have been unchecked. And then running the model, I get my orthomosaic. I'm going to turn off my my imagery products, and we can see the resolution against an imagery base map, and we get a lot more resolution. And you can run these models even deeper to get even sharper imagery. I've also created some terrain models and surface models of my imagery, which can be used for further analysis. And we can also use my zoom tools here so I can see either. And we can do some basic analysis tools within Drone to Map. I can do some. Let me turn on my mosaic again. I can do some distance measurements, and of course, I can change to the units of measurements that I prefer. I can do some volumetric measurements. And if I'm flying multispectral cameras, I can do some NDVI indices. I can do some soil moisture indices, and then I can look at my spectral profiles as well. Really neat project we worked on last fall was using drone imagery to detect algae blooms in some local lakes in southwestern Washington. And using the spectral profile of some NDVI images, we could detect where some cyanobacteria was. That was a really pretty project. Here again. And then going back to my home tab, and then you can clean up your data a bit by creating a clip area. You can clip your data. I just clipped this for demonstration purposes, and we can see that I've got my data clipped to my imagery just to clean up my data, and I can clip right in Drone to Map. Now, this is a new feature which I think is in this last release. There's another release that just came out Friday with some new features that I wasn't going to mess with for my presentation because I haven't had a chance to even read through the documentation yet, but I know there's some new features that just came out last Friday. But I believe clipping came out in the last release. With clipping without having to reprocess your the past. And then I think one of the most powerful features of this map is being able to share directly to ArcGIS Online or directly to your portal as a tile layer or a scene layer. And then you can use ArcGIS image for ArcGIS Online to do further raster analysis. You can bring your imagery directly into ArcGIS Pro with a click of a button. It'll open up your imagery as a new Pro project, and you can do further analysis in ArcGIS Pro. And you can work as those of you who have worked in Pro, you can work right within. You can pull in layers from ArcGIS Online, right through your catalog pane. You can connect to your portal and pull in layers. through the catalog pane, which really makes for seamless integration for analysis. And then you could use ArcGIS Online to create instant apps or Experience Builder, which you now can embed oriented imagery into Experience Builder. And so you have all these tools to share data right with a few clicks of a button from drone to map. And then you can continue to analyze your imagery. Back to story map here. Story map. I've just got some slides here to show some of the stuff I demonstrated over later on, different ways to share. And next I want to spend a little bit of time talking about site scanning. And I didn't want to bring in too many hiccups by connecting my iPad and trying to share over Zoom. So I created some screenshots to show you what the flight planning software through ArcGIS Flight looks like and how it works. This is an iPad app where you can create flight plans, store flight plans for multiple missions. So if you're doing change detection for change over time, you can fly missions multiple times without having to re-plan the mission. Area surveys, which is our lawnmower or oxplow pattern, crosshatch surveys, which are the oxplow pattern cross. You can do perimeter scans, which is a fantastic way to shoot video for presentation. The geospatial video logs are captured within site scans. I don't have time to go over how all that works, but you can push out video into ArcGIS Pro. With ArcGIS Flight, you can do vertical inspections, corridor scans, all within ArcGIS Flight. So a few weeks ago, a few of us from the office went out to do some field work and did some flight planning through ArcGIS Flight, and we picked this particular location because we knew it was going to be a pretty difficult location to shoot, and we knew there was going to be just getting the drone off the ground was going to be a challenge. This was within like 2 miles of the Olympia Airport, so we had to get flight authorization, and we had to do all the flight planning, and we were in a geo-locked zone. But we were able to fly this entire area within a mile of the Olympia Airport. Unlock no-fly zones, get our flight authorization, all without having to leave the ArcGIS Flight app. And I got some slides. There's some slides here to show you how we plan the flight here in a minute. In this particular case, we could only fly 200 feet, so we planned a flight at 200 feet. This is a nadir flight, so with a 0-degree gimbal angle. And I wanted to draw your attention to another feature within the application, which is train follow. So around here, where you've got really steep terrain changes, terrain follow will allow your drone to fly at 200 feet above ground level. Or 400 feet above ground level, wherever you set your flight height, it will follow the terrain. I haven't had the opportunity to mess with terrain and follow all that much. Most of the areas that I've flown are pretty flat. So, but I've seen some other demos where it indeed does work. So another powerful feature of ArcGIS Flight is the ability to bring in layers from ArcGIS Online into the application. So in this particular case, we were able to import a layer of the airport, so we know where the flight path is. This particular day, the wind, I believe, was coming out of the south, so all the airplanes were landing coming to the south. And we knew we weren't going to have an approach coming from the west or coming from the east, which would hinder our flight plans. So, you know, the ability to bring in layers from other sources and put them into your flight plan is was a big benefit to this particular flight. And then we were able to bring in a layer of our image area and overlay it with our flight plan. We were able to visualize, go back a slide here. I've got C advisories, I've got the advisories checked on. So we can see that we are indeed in a flight restricted area, and we're going to need to get proper authorization to be able to legally fly within the area. And this again is so close to the airport that we needed to unlock the no-fly zone and even to take off. You can use Airspace Link to get our LANS authorization directly within the app, and you can see here we can fly within up to 200 feet, and we're very, very, very close to the no-fly zone of 0 feet, which we would have to get applied for a waiver to fly within that area. And then there's a preset checklist that you can use to fly to make sure you've covered all your bases before you fly. So that's a quick once over of ArcGIS Flight. And again, you don't have to use ArcGIS Flight to import your imagery into DirectMap or SiteScan. Third-party flight apps will work fantastic for uploading your imagery. Okay, we've gone over a lot so far, and I want to give you just a quick once over of SiteScan and talk a little bit about the differences between SiteScan and DroneMap. So SiteScan is a fully web-based, cloud-based application. You only need a web browser to access and work with your data. All the data is processed in the cloud. All your data is stored in the cloud. So again, for those folks that have a lot of drone imagery, you don't have to worry about scaling. You don't have to worry about where your images are stored. You can share within your agency, within your shop, and as long as everybody has a SiteScan account, you can use a single sign-on to work within the app. You can, this is everybody within ESRI, where my account lives. So we can all work together, we can share data. And another powerful tool within SiteScan is the ability to manage your aircraft and your batteries and your pilots all in one place. We can see in the past month or so, we've had 57 flights with 16 different pilots and 19 aircraft and 16 batteries. So for shops that have large drone programs, you're able to manage, you know, how many hours you got in your batteries. You know, are your pilots up to date with their credentials? I uploaded my new credentials last week. You know, each pilot has a pilot profile. Here's my pilot profile. I've done 16 flights. I've updated my Part 107. You can see up here, you can see where I've flown on a hotspot map, when the dates are. So it's a great way for organizations with large drone programs to share between different users, share your aircraft safety, your checklists, and all that stuff. It's all in one place. So getting back to the fun part about SiteScan is processing your data. When you open up SiteScan, you get a map of where you've flown. These are some of the projects that I worked on. Most of them are up here in the Pacific Northwest. I made a mistake here, and I have one out here in Null Island. Not quite sure what I did there, but one of them went there. But these are all the projects that I've worked on, or I've got some learn lessons I've done. through ArcGIS Online. You can go to your ESRI Academy and you can download data to play with the applications and learn the applications. I've started a couple different processes here to go over for this demo. And Drone to Map works very similar to, SiteScan works very similar to Drone to Map. If you've got a data connection and you fly through ArcGIS Flight, you can even upload your data in the field if you've got a fast enough data connection, and then start processing before you even leave your location. But that calls for a pretty robust data connection. So most of the time, I upload my data once I get back to the office. Here, oops, I don't want my drone control. Let's show my, just like Drone Map. Here's my overlap. Here are all my individual images. That are all stitched together. And it's processing in the cloud is really nice because when you're processing through Drone to Map, it takes a lot of processing power to process this data. And oftentimes you're kind of stuck. I process a lot of larger missions overnight. I'll upload stuff and then I'll hit go and I go to bed, and then in the morning when I wake up, it'll be processed. When you work with SiteScan, push all your information into the cloud. It uploads to an Amazon server. It scales to using the resources that it needs, and then your imagery is processed, and you get an email when it's done. It doesn't take any processing power from your machine. Another great tool that works with Drone to Map and SiteScan is use of ground control points. In this particular job, we use an EROS arrow to collect ground control points. We uploaded a CSV file of the ground control lat long to SiteScan, and you can see where these ground control points are collected. And so this map should be within centimeter level accuracy of where points are on the ground. In a perfect world, I would have come over here and put some ground control over here. I would have put some ground control on other sides of the area. We'll probably do that later on. This is a pretty big area, and we just didn't have the tools to trout through the wetlands to put ground control. But once you capture your ground control and upload, okay, 2 minutes, you can capture your ground control within Drone to Map. And the last thing I'll show you is, 45 minutes goes quick, is some of the measurement tools, the volumetric measurement tools. This area here is this was an old dairy farm that is being habitat restoration. And so doing some volumetric measurements of some of this leftover things that are on the property is going to be eventually pretty important. This is an old barn storage area where there's just a bunch of hay bales that have been left. And using the measurement tools, I could figure out the volume of the hay within the storage area within a few clicks, and then I can export. They can even export that data for further analysis. And just like Drone to Map, I can share down here. I've got a share tool. I can share down ArcGIS Online and push out through different apps and web maps and so on and so forth. And that seems like a pretty good spot to wrap up here with any questions that you might have.
So thank you. That was really thorough overview of several different program options. So we appreciate it. There is a lot, and there's always more as we find out. But I'll open to the group for questions.
And the app that you have on the iPad, can that
Introduce area.
That's a good question. You can only fly one at a time legally. Unless somebody else is flying a second drone, you've got a second pilot. But yeah, you can only fly one at a time. Yeah, that's a great question. I never thought about that.
In that last one with the hay bales, so you're able, was there some water there? Hay bales were floating like that picture there? Or are they just sitting on some black ground?
They're sitting on some, it's.
Oh, it's just, okay, I can see better.
It's.
Yeah, like, what's happening? Okay, so I can see how now, so you just turned that around and you were just getting the volume of the hay bales.
The volume of the hay bales, yeah, there's a tool over here on the, these are all your tools that you can use
Yeah.
within, and this tool, I believe this one is the volume tool. You can just draw polygons and get your volumetric measurements.
And so it's calculating that from the imagery and not creating any intermediate products in the process of it?
No, it's just a PDF report that you can send out.
Yeah, okay.
Just out of personal curiosity, when was Drone Map and Site Scan released?
Gosh, John probably knows better than me.
So Drone Map was probably 8-9 years ago. And it was using the Pix4D image engine. Since then, it's been switched to
In-frames
engine. Site Scan was an acquisition that ESRI did, and that was probably 2 years ago.
Yeah, some 2 or 3 years ago. Yeah.
So it was a separate company, and they were a venture capital funded thing, and venture capitalists want their money. So they're allowed to, somebody come by us sort of thing. That's what happened.
I will list, but I'll let other people step in. One of our PLM pilots for resource stuff that also help out on the fire side of things. So full motion video.
Full motion video.
Does Drone to Map, can that ingest full motion video and pull spatial data out of that, or is that still just strictly a pro thing with the image analyst license?
That can be done through, so you can fly through ArcGIS Flight, through the Flight app in SiteScan. You can pull the geospatial video logs and then in Pro push out your, okay. I hear eventually they were working on you bringing that into SiteScan. I don't know when. I really want that to happen because I think it's amazing.
It's super complicated.
Yeah,
I mean, it's really just math, but it's still.
Yeah, it's
Okay.
one of my favorite things to work with.
Okay. You talked about elevation following and flight. What about giving it vegetation height and having it fly above the vegetation? So can you have it ingest your own vegetation layer or?
Gosh, I don't know. That's
elevation layer.
That's a great question. You write that down.
Just like for here, we're always flying above the timber, and it might only be, at one point, it might only be 100 feet above the ground, but your tree's 200 feet tall, and your next tree might be 300 feet. Well, now you're in the tree.
Yeah, that's a fantastic question.
So it can ingest a vegetation layer of some sort. Here in Western Oregon, we have a ton of LiDAR. So you could give it a EM or a vegetation model. That's just a thought.
You can definitely feed it your own elevation source.
Okay.
All right, so and I'm just pulling this out of my head. If you can feed it your own elevation, and you have your model that has the
So then you can tell it to fly for the right settings, you can tell it to fly 200 feet above.
Okay.
I think so.
Because that's something
Will you
about
on that? Will you pick on that? I'll look into that. That's an important question.
Ryan,
Yeah.
if you're okay, I'd love to be able to integrate the answer to that question
Oh.
into our notes for this meeting.
Yeah, absolutely. Yeah, bother me about that. I would love to know that. That's an important question.
I'll let someone else go with this.
Let me write that down so I don't forget to ask about that.
Well, it will be recorded.
Anyone online have any questions?
I had a question. You mentioned ArcGIS Flight, the app is only for iPads.
Right now, it's only for iPads. I believe they are working on, I don't have a release date, but I believe that they're working on the Android app as well.
And
more about that?
Yeah, there's an Android one on the horizon, and the other recent thing that happened is you can now run Android on Windows laptops. So now by extension, I would think you'd be able to hit Android, iOS, and Windows.
I hear that DJI is sunsetting their iOS app. Android. I don't know a ton about that, but that's the word on the street that I've heard about DJI.
Two more, but in your drone and map or in your flight thing, you show that FAA airspace layer. Is that a feature service or where are you grabbing?
The Lance layer or
The one where you showed like the class Echo and the class Delta or Charlie or whatever it was, like basically showing where they're coming in.
that was a layer created in ArcGIS Online, and I could import it into.
Can you share that? Because the only one I can find is not useful.
Oh, yeah, I can share that. That was shared out by a colleague of mine.
Okay.
And I think it's shared publicly.
Okay. You just point us to a link for that because that'd be useful for our flight planning.
Okay.
That's what
And you may know more about this, but one of the companies working for the FAA is one of our business partners. They're actually pushing that.
Okay.
GIS Online. I think that's the source for that.
I found the source from the FAA, but it's all stacked. So the only layer you get when you click it is the first one in the table. The way they have it published, I couldn't figure out a way to sort it, get out of it. So, but your layer looked like exactly what I was looking for.
I think the layer that I have, it may just be for the Olympia Airport.
Okay.
But where a colleague of mine created that, but I know that that's shared publicly. Okay.
I'll take a look at it.
Yeah, take a look at it.
Yeah, if you send us a note, we can connect you with the company that the FAA is using.
Okay.
To ingest that stuff.
Sure. And then the last two, which I kind of hope everybody's thinking is, what are the costs for licenses on drone and map? And I know you're going to tell me it varies, but in general.
Drone to map is there are two licenses for drone to map. There's drone to map standard and drone to map advanced. And I don't know the cost off the top of my head, but I know that drone to map standard is much cheaper than drone to map advanced. But drone to map advanced gives you 3D modeling capabilities. Drone or site scan is a tier-based license where you pay for certain tiers of processing based on the amount of images you process. But it's a soft number. So say you pay for whatever it is and you go over that, you're not going to get hit. I don't know the numbers off the top of my head. Yeah, that's why John Ruffing is supposed to be here. He can answer those.
Yeah, and I'll run mine, at least for me, so I'll run it through Jake and see what he can talk to our SRI rep that I can't talk to. So
yeah. I've got some cards, and you're welcome to ping me with any questions. I'm more than happy to answer.
I got another question. You mentioned for site scan, only some drones can interface with it. There's probably a list online I can.
There's a list online. I can put that in the chat.
Okay.
Yes. It was just updated in January.
And I think it's important to point out that if you're a government agency, a lot of them are not allowing you to use Chinese-based
covered country products.
And I just saw that Canada basically says no government agencies in Canada. And that's he's all excited because he gets a free tour of is it Free Flight?
Yeah, we get to go to Free Flight next week.
It's free.
My background is in
Uh-huh.
video production and photography, and I've been wanting to. I've had my eye on Free Flight. It's really they're a business partner, and they're really putting a lot of energy into mapping. And there's starting this relationship with those guys. They seem like a company that if you have an issue with your drone, you get an engineer on the phone, and you get some answers. answered. I've had many DJI drones and they fly fantastic, and the imagery is beautiful. But if you have an issue, I've just had an Inspire that I've never been able to get fixed. And well, that's not a problem. It's working fine. He said it comes back a month later, nothing's fixed. So, and let me before I forget.
You're not sharing your screen.
I will switch it.
Let me find that blog with the animal drones.
Okay, that'd be great. Well, if there are no more questions right now, I want to thank our speaker again for giving us so much great information and answering many questions. So appreciate you coming down to our group here and sharing your info.
Thank you so much for having us. I appreciate it.
Yeah, thank you. With that kind of adjourns our meeting. We did have time if there's still snacks, if people want to hang out. Yes, there is a survey which will either